Hi, welcome back, and congratulations on taking your first step into Houdini. Today, we're covering some of the basics and getting you started with our first project. By the end of the video, you'll have created a scene from scratch, added all the required elements to complete your first shot, and then rendered that out. The final result of what we'll be making today is this render shown right here. We'll set up everything and I'll explain it all as we go, and I will do so without expecting any Houdini knowledge. So if you're familiar with Houdini and already know some of the things that we'll be covering, that's great. But if you're brand new to Houdini or brand new to 3D in general, try your best to follow along and ask questions in the comments. You might need to re-watch this video a few times to fully get a good grasp on what we'll be covering. And I encourage you, don't give up. The effort you put in will be worth it, I promise. The project files are also available for download in the description, so go ahead and grab those and let's get started. Now, before we open Houdini, we need to cover a few ground rules. 1. This channel and the information and workflows that I'll share are created with the intention of giving away the knowledge that I wish I had when I was learning Houdini for the first time. Or in other words, if current me was tasked with teaching a younger version of myself how to use and learn Houdini, this is what I would share in the order I would try to teach it in. This doesn't mean it is the only way to learn Houdini, it's just the way I would have wanted to learn and a way to work that I think is a lot of fun. 2. The workflows and information that I'll be sharing are techniques that are proven to have worked for me. I'm not making any claims saying that this is the only way to use Houdini or the only way to learn Houdini. It's just the way I choose to do so and my personal favorite way of working. These workflows I have used on real projects with real clients in the real world. I've never worked in a large studio, and my professional work consists of small teams of a few artists at most. I'm sure bigger studios have their own ways of doing things in Houdini, but since I have no experience at any of those studios, I'm not able to share anything on how they might use Houdini. Now, to give you some context into my experience so you have a better understanding on how I approach the software. I have worked as a generalist and freelancing 3D artist full-time for the past 6 years. Throughout those years, I have completed projects using Houdini, Cinema 4D, Blender, and Unreal Engine. And after years of using all these different programs and approaches to different projects, Houdini has been my favorite software to work in, and also I have found it to be the most flexible and most rewarding software to learn. As I share this information and start this channel, I do need you to keep a few things in mind, and we need to set some ground rules. 1. I'm still learning too. The way I use Houdini and the way I'll share with you is a way that works for me, and has allowed me to create cool projects in the software in an enjoyable and reliable way. It has also let me make a living doing this, which to some degree means that what I'm sharing does work, at least for me. What I do may not be the most optimal or efficient way to do everything, as specific use cases and different projects sometimes require different approaches entirely. 2. As you get more comfortable in the software, you may choose to do things differently than how I do. That's great. You might see a task and have an idea on how to approach it or implement it differently, and you should definitely try that. If you like that way more, then stick with it. 3. I am not a Houdini expert. I'm just a 3D artist who uses Houdini. Some of you may know things that I don't, so please let me know if I explain something incorrectly or if I misrepresent a specific topic. We'll be covering some complicated topics that I am still in the process of learning too, so my understanding and explanations of these will be from my point of view and my current experience. An example of this is USD, which is a technology invented by Pixar. I'll try and share my limited knowledge of USD in a way that makes sense, in a way that lets us achieve our goals. The way I navigate and approach USD is in a way that helps me create my projects, but I'm sure there are better ways of working with it depending on what your job is or what size of studio you work at. 4. This channel, in its entirety, is created on a project-based approach with an ultimate goal of being able to render everything we make and being able to do so as a solo artist. For that reason, the general approach to Houdini that I'll share is one that is focused on an artist working alone, meaning we will not have certain constraints based on team members or larger studio pipelines. I have never worked with a large Houdini team, so I do not know how to teach that. I'll stick to my lane and just share only what I've actually put into practice myself. And finally, project files and assets will be included as often as I can. I already have a few cool projects planned, so I'm excited to share those once I get to them. So please download, follow along, and make mistakes. That's the best way to learn. Now that we've finished with the boring stuff, let's get started on what we're really here for. Since this channel and its content is aimed at anyone who wants to learn Houdini with no experience required, I'll try to explain the basics as they come up. For those of you who have used Houdini before, think of this as a review. And for those of you new to Houdini, I encourage you to also do research and look up things on your own. I intentionally will not cover every part of Houdini or explain what every node does, because I'm sure there are plenty of tutorials out there that do that. The goal here and the goal with this channel is to teach you how to use Houdini first. And once you're comfortable with that, you'll have a good foundation to continue learning and following along with the future projects on this channel. You'll gain confidence as we keep repeating the same steps over and over, and slowly begin to expand your knowledge into the other and more complicated aspects of Houdini. Once you've followed along with enough of these projects, you should have the confidence to create your own shots and scenes without needing to follow these videos step by step. In all honesty, if I do what I'm trying to do and you learn Houdini well, you should be able to stop watching these videos entirely and go make projects on your own. But unfortunately, that would mean you would stop watching my videos altogether. So let's hope that by the time you've become a Houdini wizard, you like me enough to keep watching for fun and to share this content with others. Now, let's get into some explanation in Houdini 101 to help set the stage. Houdini is a complicated software, but the best way I've found to think of it is to compare it to an operating system. For example, on your computer, you'll have lots of different programs, maybe Microsoft Word, PowerPoint, Adobe Photoshop, Final Cut Pro, or Keynote. Each different software lets you handle data in a different way. With these softwares, that data is most commonly in the format of text, video, images, or audio. With each software, you can do different things to different types of data. You could color correct a photo in Photoshop, add text to a poster in PowerPoint, or add audio to a video in Final Cut. You can also make similar things in different types of software. For example, if we wanted to create a poster, we could make that in Photoshop, PowerPoint, or even Microsoft Word. There would be a slightly different way of working within each of these softwares, and some people may have a preferred way of doing it. In fact, you might make the decision of which software to use depending on your specific use case. Houdini can deal with data in a similar way that our operating system programs can. Houdini has a lot of different areas, or contexts as they are called, in which we can work with this data. These contexts I like to think of as programs on our Houdini computer. In each context, you can do different things with different types of data, and you can pass data back and forth between them. You can import and share the data, or you could do simulations in one context and render those simulations in a different context. Let's consider an example. Say we make a cube in one context, export it to a different context, do smoothing, and turn this cube into a sphere, and then import it back into our first context to continue working with and to render. This would be essentially similar to us taking a photo from a PowerPoint presentation, exporting it to color correct that photo in Photoshop, and adding it back into our PowerPoint presentation. Here in this example, our current workflow would look like this. We take an image from our computer and import it into PowerPoint. We then export that photo from PowerPoint to Photoshop, and then import it back into PowerPoint. Now the question we might ask is, why wouldn't we just skip the first PowerPoint import and go straight to Photoshop and then import that to PowerPoint? Since this has fewer steps, does that make it a better workflow? The answer, I would argue, is dependent on your specific use case and ultimately up for you to decide. Both workflows can be equally valid as they both accomplish the same task. In some cases, we might choose a workflow with extra steps because it makes it easier for us to do or is a more enjoyable way to work. In Houdini, we will have many situations similar to this, and ultimately, it will be up for you to decide on how you like to work, and equally important, how you are able to stay organized. Now, what gets interesting is that even a task that seems as simple as this PowerPoint photo example might actually have a lot of extra factors we didn't think about. For example, when we start to actually implement this task, we will run into a few more specifics that we need to resolve, such as what file format will we have? Will it be PNG, JPEG, EXR? Will it be black and white, RGB color? What resolution will the photo be? If we need to send the PowerPoint by email, do we need to consider how much storage the image takes up? If the image is a small logo in the corner, then maybe a small image size would work well. But if it's a big background photo, then maybe we need full 4K resolution. This divergence of one single task turning into many smaller decisions is a common occurrence in 3D in general, and not just with Houdini. An important question now, as we are in the process of making these decisions and setting up our own workflows, is what happens if somewhere along our creative journey we make a decision and then later in time want to change that decision and go back in our workflow to do something different. This is where workflows are split into two types of categories. The first category are workflows that when we want to change something we did earlier, we have to go back to that step, make our change, and then make each following decision again. In other words, our workflow doesn't remember the steps we took. This is what we call a destructive workflow. Now, doing that change one time might not be too bad, but if you need to change 100 things over and over and don't know when you'll need to change them, that tedious work can build up and get pretty annoying. Now, what if there was a second category of workflows in which every step and decision we made was remembered and kept track of? And what if there was a 3D software that allowed us to work in exactly that way? These workflows are what we call procedural. Instead of us making all the decisions once and not being able to change them later, we can save out the steps in the order we make the decisions in. This procedural way of working gives us the ability to change any one of those steps at a later time, and then everything else after that step just works. Basically, instead of baking the cake ourselves, we just write the recipe, give it to Houdini, and let it cook. Now, we have just covered a lot of information, so let's pause to take a little break before we continue and create our shot. While we're waiting, let's hear a quick word from our sponsor, this channel. I've put a lot of effort into this video and a lot of thought into the ideas I'm trying to share with you. Learning Houdini over the past few years has been a long and tough road for me, but I sincerely hope I'm able to help you at least a little bit along your journey. If you're feeling generous, the most helpful thing you'd be able to do is to share this channel with one other artist and help it grow. That's all. Thank you, and let's get back to learning. This is the shot we'll be creating today, so let's get started. Now, instead of jumping straight into Houdini and dropping down nodes, we'll take a minute to plan and break down what we need to do to accomplish our goal of successfully recreating this image. Let's call this image our reference, and let's begin by thinking about approaching this with our framework. So, step 1, list our goal. Our goal here is to recreate our reference image as closely as possible. Next, break it down. Here, we break down the goal into multiple distinct and less intimidating chunks that we can then implement individually. These chunks are distinct pieces or parts of the scene that we'll need to assemble in order for us to successfully complete the shot. Now, pause the video and list out as many different ones as you can think of. I came up with 6 chunks as I was putting together the scene. I really do encourage you to give this at least a 30-second effort. By building the skill to break down a reference image into smaller chunks, you'll begin to build an understanding of how you can reconstruct your own shots from scratch. Now that you've taken time to think about the chunks, here are the ones I came up with. 1. The background, the ground and back wall that our objects are sitting on. 2. The props, the cube, spheres, and tube that are at the center and focus of our image. 3. A few materials that define the texture and surface of each object. 4. Lights. Some lights that brighten the scene and add reflections and shadows. A quick tip for you is if we look closely, we can guess and get a sense of where the lights are placed based off the shadows and reflections in the image. This is a skill you will develop with time and improve with experience. 5. Camera. The point of view we are seeing the scene from. 6. Render settings. In this case, these render settings are what tell Houdini what size our image should be when we render it out. In this case, that is 1080 pixels by 1350 pixels. Now, this is a good start to breaking down our scene, but we can still go further. Let's review the reference again and now list out the distinct tasks we can do to implement each chunk. The 6 chunks we have now are shown here: the background, the props, the materials, the lights, the camera, and the render settings. These tasks we list out should be phrased as single, actionable items with one action per task. If you want, you can pause the video again and think about what tasks might be involved in implementing these chunks. To save time, I won't read these aloud, but you should pause the video and review them yourself. See if these were similar to the tasks you initially thought about. Now, seeing this list of tasks makes this scene a lot more straightforward to set up, but we're not done yet. First, let's assign each chunk as an individual color to help stay organized. Then, let's represent each individual task as a single dot. These dots will represent the action of completing that task. Now, if we listed out the tasks one by one in the order we can complete them, we will start to see how they fit together. Let's start here at the top and work our way down as we go. First, we have the background tasks, then the props, followed by the materials, the lights, our camera, and then finally the render settings. Now, this is looking a bit better, but let's make some more room and we'll add a point at our start and end and connect the 2 dots. Let's call this our network. Now imagine our friend Houdini is able to start at the top of the network graph and work his way down towards the end. As he goes down the graph, he can complete tasks along the way. Our goal now is to arrange these tasks or these dots along his path so that he can complete them all for us. But to make it more challenging, we'll give him 2 rules to follow. 1. Houdini can only move down the graph. And 2. The only information Houdini is able to see or operate on is information that is above him in the graph. Anything later in the graph he has no idea exists and isn't able to do anything with. Let's explore how these rules work. Imagine Houdini is here in our graph. Let's take a few of our tasks and think about how we would assign those to Houdini. 1. Create a cube. 2. Move the cube. 3. Create a material. And 4. Assign that material to the cube. If we connect our task, move the cube to our network, and ask Houdini to complete this task, it would have no idea what cube we're talking about and it would fail. Even if we added this task of creating the cube later to the network by connecting it, since Houdini can only see above in our graph and has no idea of what's below, it would still fail and not be able to complete the task. So the place we need to connect this task of creating the cube is before we tell Houdini to move the cube. Now, let's keep going. Let's tell Houdini to assign a material to our cube and see what happens. Houdini now doesn't know what material we're talking about and isn't able to complete the task. In a similar way to our cube, we have to now assign the task of creating the material to Houdini before we tell it to assign that material to the cube. Now this is starting to make some more sense, and we can see how these rules work while we arrange our tasks and assign them to Houdini. But if we kept going and wanted to add the rest of our tasks, or maybe even a few hundred more, like we'll be doing in later projects, we might start to see an organizational problem. If we kept adding the tasks the same way, by just adding them one after another, that would get very cluttered and our nice simple network would be an endless stack of hundreds of dots. This would make it a clutter to work with, and you'd get lost when trying to come back a week or two later, trying to remember where everything was. So let's start to think about how we can use our rules to organize this network some more. To make it more fun, let's add 3 more tasks. We'll assign create the floor, move the floor, and assign material to the floor by connecting those into our network. Now this line is getting a little bit cluttered, so let's move this task of create the floor to the side. Now at this point in our network, Houdini has the same issue as before. it doesn't know what floor we're talking about. So let's fix that by connecting it again. Great, but we can do better. We can move both these to the side, and that arrangement still follows our rules and still gives Houdini all the information it needs to complete the task. Let's do the same thing with the cube, and we'll start to clean up our network a little bit. Now, if we tried the same thing with these material tasks, we'll run into a problem again. So we can fix this by rearranging our network slightly. What gets really cool is that there are many different network arrangements that are all still valid. These 4 arrangements here show different ways we can connect everything, but still allow Houdini to execute each task with the information it needs. This flexibility is one of my favorite things about working in Houdini, and we'll expand on this idea in later projects and see lots of cool things you can do with this thinking. Now, if we go back to look at all the tasks we had listed out when we broke down our scene, we can start to think about how all these can be arranged in a way that lets Houdini complete them all, but also in a way that stays organized and efficient for us to work with and navigate. In fact, if we compare this network to our final network in Houdini that we're about to create, we can see lots of similarities. Now, onto Houdini implementation. The way I've formatted the Houdini side of the lesson is as follows. First, I'll walk you through a quick introduction for what we'll need to know today. I'll cover some basics of the UI and where we'll be working in the actual software. Now, as I mentioned earlier, the way I'll explain things is the way and the format that would have worked best for me when I was learning. So this won't be your traditional Houdini tutorial. After our introduction, the next 2 parts are designed for you to sit back and relax without following along. I'll explain how all tasks we listed out earlier are implemented in the network. I'll then showcase a second version of the network that creates the same scene and accomplishes the same goal, but with a little bit better of a workflow. Now, remember how we mentioned that some workflows with extra steps could be helpful? This is one of those exact situations. The network I'll first be showing you is overkill and intentionally uses more nodes than it needs to. I did this because I wanted to show you a one-to-one correspondence with our tasks that we are implementing and the nodes in the network. And then later, you'll see how you can do the same thing with fewer nodes. This is also part of the reason why you should not try to follow along with the first parts. Watching me navigate and explain the scene will help connect a lot of dots into how the graph has been structured and how it corresponds to our tasks. You'll also see how I navigate and move around Houdini, and that will make it more enjoyable for you to follow along with the third part if this is your first time ever opening up the software. That final part, I'll be creating a similar network from scratch, and you'll be able to follow along with that step by step. Now, these next few parts of the video, I'll try to do live, so without a script and without any editing. This will be helpful because if I run into any issues, I'll work to fix them and debug them with you. You'll be able to see how I review and move nodes, and also I'll try to explain my thinking as I go. This is my first attempt at working while recording, so please excuse any hiccups we might run into. Also, if you have feedback on which style you like more, please do let me know. Since this is the first video of many, the way I put together videos is likely to change depending on the feedback you give me. Now, let's open Houdini and get started. Welcome back and welcome to Houdini. If you've downloaded the files from the description and opened them up, this is what it should look like. If this is your first time opening Houdini, try to follow along, and if you do need to, look up documentation or other quick references on Houdini UI. I will explain what I'm doing, but I won't explain everything because I do want to keep this video a reasonable length. This video is also going to be done without a lot of editing, so if I make mistakes, I'll try to leave those in, and then that way you can see how I fix them or debug them. Also, this is my first time working while recording, so if I do misspeak or accidentally call a node by the wrong name, please excuse that. I'm not quite used to thinking out loud, so we're going to practice and see how it goes. Awesome. So the first thing I'm going to start doing is I'm going to close all these panels, and I'm going to open up the ones that we need to do and create our own workspace, and I'm going to arrange that in the way I like to work. So I'm going to close this top one, which is the shelf tool, or the shelf with all the shelf tools on. I'm also going to start closing all of these. I'll explain them as we add them back in. But one more quick note is if you accidentally do close these, or during the lesson you close them and want to get back, what you can do is click up here on build, reload current desktop, give it a few seconds, and it'll bring you back. My desktop actually is now dark, and the way to change that is to hit D, background, dark, on light, and you have to be hovering over your scene view while doing that. So you can set this up however you'd like, and you can save it as default, and that way it'll work across different files. So now again, to close down everything and then open them back up. These we don't really need, and we'll also add the ones we do need. I like to work with only the things I actually need to see and have relevant at different times. All right, looks like we can't close this last one. So let's let's start with scene view. So this will be our viewport. We navigate by clicking left click, middle mouse button to pan, and right click and drag to zoom. We can split this pane by going to the top right, split pane left right, and now we're going to open up here in this right one. We're going to do a network view. It's going to take a second to load because I'm recording. We're also going to split again left right, and it's going to open up a parameter view on the right. We want that there. We're going to close out this scene view here, or excuse me, this network view. Told you it would happen. All right, so now we're going to split this one again, top bottom. In this bottom one, we're going to add a network view. The reason I do this is actually I like to be able to zoom in and look at these images while also being able to work. So this is a nice little handy way to keep these there. I'm going to pin this to 2, and I'm going to pin the other ones to 1. And we'll do that so then when we select stuff in the bottom right or select stuff in this one, it won't mess up what we have selected. And now actually this is a good case. This little icon, this dot here in the middle, you can click and drag to move them. If you click and accidentally let go, that'll swap them. So just click it again and it'll swap them back. Now we're going to click this pin again. 1. That should be good, but we're actually going to add one more, and we're going to add a geometry spreadsheet down here. We'll get into this later, but this shows information about the geometry, and then when we switch to the different context, Solaris or the stage context, it'll show information about our USD layout tree, our scene graph, which we'll also get into later. Now, you can see this, the CH. This is one of the contexts we're in, but we're actually going to want to work out of the OBJ context for now. So click that and switch. And now you can see it actually switched all the other ones that were linked, which is a great thing. And now I'm going to pin this one, number 1. Awesome. Now we should be good to go. So I set up the UI, show you how to move these. Actually, one more thing. If we go up to build, save current desktop as, I'm just going to make sure everything's pinned correctly. Awesome. Looks good. And I'm going to say this is lesson, let's say 01. Let's say workspace. And I'll say V3. Now, again, I'm recording, so some stuff might glitch out a little bit. And now you can see I've done this a few times, but this is our one here. We can now select these actually. So say we did build. This will keep it the same, but if we go here, reload desktop, it'll have what we opened, and say we were in a different spot, we wanted to get back to where we were, we can now go build and open the one we just made. Awesome. Now let's keep going. We're going to see viewport navigation I already covered. So you just remember left click, middle mouse, right click to zoom in and out. We did change backgrounds. We're going to create some new nodes. I'll show you different on the display flags, which are going to be important. And then I'll show you a few workflow tips. So first, to create nodes, what we're going to do is we're going to hit tab. That'll open up a search bar, and we can add nodes that are relevant to the context we're in. So if we add a null, we'll see this null. We'll see it show up in our viewport or our scene view, and we can hide it and show it. I'm going to delete this by dragging and selecting. You can click and drag nodes, and then I'm going to delete that one, and I'm going to add a geometry container. Now, right now we're at the object level. To actually add objects in geometry, we're going to have to go inside this. So we're going to double click it, and now we're at SOPs, or the geometry level. To go back, you can hit U, which will take you up in the network view, and we can hit I to go inside the network view. So if you ever get lost, you can also go back to OBJ, select it, and that's the first one. And you'll notice as we go down, we dive inside, it adds the path of where we're going up here. This will be helpful later. So say now we add a box, we do tab, BOX, we add that, and now if we wanted to do a color, we add a color, and we hit tab again. Now when we drop a node, if we type it in and hit enter, it'll just add it. But I'm going to select these and delete them. If we select the box, hit tab, color, and then hold shift and hit enter, it'll connect it automatically. Now I'm going to color that red, and now I'm going to alt drag to duplicate the node. It'll stay connected. I'm going to color this one green. Now what's happening here is Houdini creates a box. We see that, we see the points here, and the box is made up of individual points. We'll get into this later if we're doing any more procedural geometry, which we most likely will do. This left side, so this geometry stream, what it's doing is adding a color, and it's adding the color as a color attribute, and that attribute is recognized by Houdini as color, which is an important thing. We'll also get into that later, but don't worry about that too much now. We can color the nodes if we'd like by hitting C, and then I'll pop up this little color panel. We can select a node, click it. We can also select a node, click and drag, and there we go. Red here, green here. Now say we wanted to do something else. Say we wanted to move the object. We can add a transform, again typing in transform, and hit enter, add transform, or we can select it, hit transform, and then hold down shift and hit enter. It'll automatically connect it. To edit these, we can either hit enter and it'll pop up with a handle. This looks like it was hidden accidentally, but this left side here shows some helpful tools. You can also look this up in the documentation, so I'm not going to explain it, but escape to get out of that, enter, and then some nodes have these handles or gizmos in other software they're sometimes called, and they let us click and drag and do stuff. So now you can see an example here. We have this node added box, we added a color which is red, and now we're transforming and we're seeing the selected node. But we don't actually see this in the viewport because we don't have the display flag set, which is this blue one. So if we set the display flag, the blue flag here on this icon, on this node, there we go. Now we see it active. We can also bypass, which is skipping nodes in the network. And we can use that yellow flag here, and that skips it. That says whatever's here on this node, don't do. So now don't transform it. There we go. Don't color it. Another thing we can do is disconnect nodes. We can shake it, and that'll disconnect it from the network, and you can drag it and put it on. That'll connect it back in. Or to disconnect, you can hit Y. It'll pop up a scissors icon. You click and drag, and there you go. Control Z will also undo that. So let's shake this, disconnect it, and we can now connect it below, and it'll do the same thing. But now if we wanted to bypass this node, we can disable that, and then nothing happens. Awesome. And now we're going to say sample nodes and interaction. So there we go. We just added a few nodes, showed you how to use them, and how we can hide and display this one if needed. One other thing to note is if you added another one, geometry here, let's say, let's do blue box, because we'll make a blue box. Go inside. This is ghosted. So now, looks like I clicked on that and it jumped me to that one. So now here I'm in the other node, the other geometry. I hit U to go up, and now I'm inside this one. I want to go into blue box. I'm going to add a box. Again, BOX, type it in, shift enter to connect. For color, we want to connect that. Now I'm going to make this blue. And now we see them both. If we don't want to see that one, we can either go U to back up. We can hide the one we don't want to see. We could hide them both. Or if we want to hide one or hide the others as we dive in, we can double click inside here. And then this setting up here is ghost other objects. Currently it's ghosting. We can either show them, which sets them into full visibility, ghost them, which hides them, or hides, which just hides them if you're inside one geometry container. Let's go up. U. I'll delete that because we don't need that. And then I'll show you now how to add these images just in case they're not here, or if you want to add your own. So to do that, we're going to go up here, create a new background image, click it. It'll open up this file browser. This is the hip directory. So hip is the variable inside Houdini that stores wherever the current Houdini file you have open is located on your disk. So if we double click and hip, if you download these actually correctly, these images should be in the same location as your hip file. So I'm going to open up one of these. It's going to give it a second to load. There we go. Now it's saved here, but we can't move it. If we do want to move it here, we can go to Tools, Edit Background Image. Now we'll see this little yellow box around. We can click and drag. We can also click to resize. And now if we want to be able to move them without seeing these yellow boxes, we can't just do that. We can't hide those tools again, so we have to go back here, Edit Background Images. I'm going to add a null. Click this little link here, drag it there, and null. Now if I do that, Edit Background, I can click and drag, and you've seen that's what I've done with these here. Awesome. So now we're doing well, making good progress. Again, the reason I like to have this bottom network here with number 2 is so I can look at these little images as we're moving and then not have to worry about accidentally clicking anything else. Great. So now the next thing I'm going to do is I'm going to pause and then we're going to reset. All right, let's keep going and we're going to explore what these nodes are. So right now we're in the object level. If we double click inside this LOP network, it's going to change to Solaris. Now we're in Solaris or stage, which is Houdini's rendering, lighting, and layout context. So again, if I hit up, it'll take us out. And if we dive inside the other one, that's also a Solaris context. Another way you can access this same context is by going up here into stage, and it'll put us in the same workspace, but our nodes and setups aren't here because they weren't made in stage. They were made in a LOPnet inside the object level. If we open these up, for example, copy and paste, we could move them to stage in this level here. But if we add multiple setups, it does get confusing. So my preference is to work inside LOPnets in the object level. Just a quick tip, you're welcome to work either way. All right, I'm going to go back, object level, and then open up this LOP network. Now I'm going to close this pane right here, slide this out, and open up our little cheat sheet here for Solaris. So Solaris is Houdini's layout, lighting, and rendering context. It's the primary context we're going to work out of, and also the best way to set up shots in my opinion. There's other ways in Houdini with the object level and some things there, and that might be how you've seen older tutorials. But Solaris is the newest way to be working. It's a few years old in Houdini, and it's the foundation that's been built upon USD. So USD is Pixar's file format that they created, and it's very, very, very interesting and also very difficult and complicated one. So if you want to look into it, you definitely can, but we're not going to cover a lot of it here. The only things you do need to know is that Solaris and Stage works and modifies USD. LOPs, or lighting operators, are the nodes and tools. So these right here are LOPs. The nodes and tools that we use to modify the things in the stage context. And then everything in USD is called a primitive. So nearly everything, there's a few exceptions. So this camera here is a primitive, and we'll see how these work later. These materials here all create primitives. These cubes, these SOP create nodes, which we'll also dive into later, create primitives that are all listed out here in our scene graph. This is going to be probably the most important thing that we use in Solaris because it lists everything in our tree, in our scene, and also shows us the relationship between them. So these little nodes we can open and close. They're pretty much the same as folders, and inside we'll arrange and organize everything here in a way that makes sense for us to work. All right, another thing that's important, this is also listed on the side effects Houdini documentation, is this quote here: because USD is a very comprehensive framework, it is not simple. LOPs is designed so you don't need to know about the underlying USD structure. So another way you can work with Solaris is by just using these nodes and entirely ignoring the scene graph. But we're going to do a little hybrid mix of Solaris while keeping track of what's going on in the USD structure, because that's going to make it a lot easier once our scenes get more complex and when we're doing things such as multiple cameras in the same scene, or even multiple lighting setups for the same environment. Awesome. I think that's pretty much all we need here. So next, we're going to jump in and seeing how exactly this network relates to this layout here, which we developed earlier in this video, and then how each of these nodes actually relate to an exact one of these tasks. So like I had mentioned earlier, there's some different ways to work. This is an overkill, so this way is a little bit more involved than you typically would do. But the reason I set it up like this is because this lets us see a one-to-one relationship with tasks and nodes. Later in the next one, if we go up, we can actually go to the next example. We'll see this has fewer nodes. This is a little bit more of an efficient way to work, but we'll cover this next actually. All right, so up, back into this one, and let's keep going. Now I'm going to close this one back, open it, and we're just going to start working through the tasks and seeing how they work in this structure. All right, let's start looking through the scene graph and seeing exactly how each of these tasks are implemented. The first node we have here is a primitive node. This creates empty primitives. Remember how we learned that everything in USD and everything in Solaris is a primitive. This creates empty primitives that we're going to use to organize everything later. These nodes here create our background, and these also create them as primitives, and then this node, a graphed branches node, is what merges the right side here, the background, onto the left side. So now under this background, we've added the floor and the wall. Inside these, this is the SOP create, which lets us now work in the geometry or object context. And we can add box. We can add any of our geometry we want. We'll do more complicated stuff later, but right now it's just a grid. And now we have this null selected. The important thing to know, okay, whoops, I accidentally hit the back and now it took me to stage. So to get back to where I was, I'm going to hit stage up here, go to object context. Now we're going to jump back into our project states, example 1. Now we're here and we're going to jump into floor. Now what I was saying was whatever is currently selected with the display flag is what's going to be imported up into stage. So if we do a sphere, set this with the display flag and hit U to go up, we'll see that that is now imported into our stage context. So we're going to put it back to floor and I'm going to continue. So this creates the floor. This one sets the primitive and moves the floor by 1 unit. The floor is coming in as a primitive, which is named based on this right here, which is a parameter expression, and it's $OS, which means operator string. This is just whatever the name of the current node is, and it's going to set that as the primitive name here in our scene graph path. So if we change this to floor superfloor, that'll be named differently and it will reflect in the scene graph path. So we'll change that back. See, transform operates on the primitive floor and it moves at 1. The wall, same thing, just a grid, display flag set here. Import this up to $OS. You can hit middle mouse click to see what it evaluates to, this operator string or parameter expression. That'll save it as wall here in our scene graph path. And then we'll move that by selecting the primitive we want to move and choosing the amount we'd like to move. Here we can type in 1 here, 5 here, or you can also middle mouse click and drag left and right to select, and you can drag up and down to change the increments you'll be moving them in. We'll keep it at 5 because that's what we had before. These two get merged, then that is grafted in. The branches are grafted in to the scene graph we have established up here. Next up, we're going to be working and organizing inside this props primitive. So we can see this node down here is going to merge all of these into props. These are created in a very similar way inside with the SOP create, which lets us edit and work in the geometry context. We create a box. We can zoom into the box. Another thing we can do is hit F to frame or hit G to go home, which will frame and move the camera. So we create a box. We give it a very tiny bevel. You zoom in more, you can see it more. give it a very tiny bevel, and then match the size. And this node is used to set it on the floor. So we have it right here, which is a little bit below 0, 0, 0, which is our world origin. And now we're going to match its size by the y coordinates. So the minimum we're going to set to same, which sets the minimum and this to the world origin here. This node can do other stuff, but we won't worry about that yet. Now we select the display flag for out cube. We hit U to go up, and now we see if we select this display flag again, that's our cube. This is also named in a similar way, /cube, stored here in our scene graph, cube. Now we're going to move the cube same way. We select the primitives we'd like to operate on, and we choose the amount we'd like to move it by. This is 45, so I'll keep it the same. Same thing for the sphere. We create a sphere. Here's another new node, subdivide, which subdivides the geometry that's incoming. We move that, and then we're going to match the size, so we're going to justify again. Looks like here I've also centered. So this one moves it now back to the origin. So we can center on the X, put min on the Y, and center on the Z, which is what this node is set to do now. So this transform, technically we don't really need at all. So let me bypass that, or we can even set it up like that. So either one of those will work, but this match size essentially negates what the transform just did. So this could be deleted, but I'm going to Control Z to keep it there. Now set the display flag on what we want out, go up. Next to small sphere, this is the exact same, but it's just a little bit smaller. Next one is tube, which we set the display flag. Jump in, we'll see a tube, which is another primitive type here. And now quick thing, let's see. Well, primitives are different in USD than they are in geometry context. So right here it says primitive properties. That's going to be a different type of primitive, which is a geometry primitive. So that's like typically a face in Blender or different types of objects in other softwares. But we're not going to worry about that yet. Here, this does a poly bevel, which bevels, again, a very small amount. Match size was set to the 0, and then a tube. We go up, transform the tube. Again, we select the primitives we'd like to operate on. Right in here, and we choose the amount we'd like to rotate and translate. Then we merge those all together. Those are all stored here. And now this graph branches node again, takes the source prim path, which is the right side here, and puts it on the left side at this destination. So everything here goes to this /props primitive. We can click to open and close. Next, materials. So if we select here, we don't see anything in the viewport because these are stored as primitives here and they don't have any viewport representation. So if we double click to open, give it a second, this is a material X subnetwork. So if we type MT, we can see material X builder. This is exactly what that is. Double click that to go inside. And this is how you'll define the surface of objects and the materials on objects. And we'll use a lot of different things later with textures and more complicated shading. But right now, all we have here is the same default, and we just changed two things. We just set a base color and a specular roughness, which we'll also get into later. We do the same thing with the purple color. We hit C, remember again, to color these nodes. And then we do the same thing with the blue material, an orange one, and a red one. One more thing here. The color of the actual node, right now it's set to red for the material color. This has no effect on that color at all. This is purely for visualization and organization in the actual node network. So I'm going to change it back to a nice red we like. Hit U to go up. We'll see that merges the materials, and now we have all these different materials, which again are currently named not by the operator string. We can see that here. They're named by the names of these inside. So gray rough is the material, and it brings out the VOP, which is this what it's called. It's a VOP, which is another thing we're not going to get into, but you're welcome to look that up. It imports that up, and then it names it material path. So right now we could say gray rough, new material. If I can type correctly, and then I'll change the name of that. The subnetwork name inside here doesn't have to match. So now it'll automatically remember that you changed the name and it will change it inside here, but they don't have to be the same. So you can name that whatever you'd like. U to go up, we're going to delete that and keep it to what it was, which was gray rough. Awesome, let's keep going. This again merges the materials, which are all stored here under this primitive, to the left side, and we're going to store them under this materials one again, which remember we defined up here with slash materials. Next, we assign the materials. So this isn't the best way to do it because we could all do this assignments in a single node. Oops, I just disconnected, so I'll click again here and connect it back up. But what this one does is this selects this material path, which is again in here, and we can set this by either typing it out or dragging from the scene graph path all the way up to there, and it's going to assign that to every primitive under the background hierarchy. So under here, background, with this asterisk, this is a wild card, so anything under here counts, and we're going to assign that to there. We select that and we can see, this is hard to see because it's just gray, but if we go to the next one, it does purple. The next one assigns a blue material with blue material rough, blue rough material, or metal, excuse me, to props slash tube. So that's props here and tube there. We just drag and dropped it. Then we do orange, then we do red. This red material is a glass material, which I'll actually show you really quick. Jump inside here. The glass property is set with transmission. We set that weight to 1, and the color is the color of the refraction in the transmission. U to go up, and again U to go up. Next we have lights. These lights are set up in a very similar way. They're stored based on the name of OS, operator string, but now they've been placed inside this slash lights primitive. So this will give them another drop down here. That'll store them as well. And if we see, this is just a dome light, which we can move around. We hit enter and we can drag and move it around. Since this is an HDRI, it comes from everywhere. So technically moving it around really wouldn't do anything for position. But if we did rotate it, that would change the angle the HDRI is shining on the scene. So you can click and drag and move this, or middle mouse button actually it was, and then we can change the rotation. This is a point light, which we see here. This is another point light, which we see here, and I just hit escape. So if you hit enter, you can see a couple extra tips while using these. You can hit escape to hide those. One other thing here is if you accidentally, these disappear, this little widget icon displays the guides for where the lights are. This is only in the viewport, so you'll still be able to see them in the render, but in the viewport you can hide them if you need to. This again transforms light slash point light. So this will change anything point light and move it based on this position. This wildcard means that anything after the name point light will still be moved. So we're going to move point light left. If we change the name to point light left version 2, this will still move it, and we don't have to type in explicitly the exact same name. That'll come into help later if we want to organize and move multiple lights. And notice how the name of this does change. So same, another thing, a point light. Here properties, we've set the color. We'll also get into these later as we set up the scene. We move it, we merge it, and then we move it back, graph branches, and merge it into our bigger scene graph. So now this is everything, but we can't see the cameras. So if we clicked up here, which is how you select cameras, you'll notice there's nothing here, and that's because they're added later. This adds one camera and places it in the scene, and you can see right now, if we select above this display flag, will be no camera. So right now, camera disappears. We select down here, the camera shows up, and that's saved up in the top right here, camera slash OS, camera slash operating string. So if we change the name of this to super camera, it'll change the name here, and that'll still be stored in the same location. Another thing is this little icon hides and shows the cameras in the view, the scene view or viewport, I might call it. I'm used to working in different softwares as well. So hide and show that. This one we have camera B, camera C. One more quick thing, I accidentally did it. You can hold down Control and you'll select one. Again, shake and you'll delete the nodes or disconnect them. If you hold down Control and move, it'll move everything below. And if you hold down Shift and move, you can move everything above. So that's very helpful too. Another one is if you select multiple ones, say they get out of order, you can select them, hold down A, and swipe in the direction, and they'll automatically be arranged. So super cool tip there. Now if we select here up camera C, we'll see it. We'll view in the camera's position, and then if we go from perspective, which is VK Vulkan, which is just the default viewport, we can change to Karma XPU. Give it a second to load, and this will render our scene with everything. We can now hide, like I mentioned, these little light icons. Another thing you can do is go to Karma XPU, correction toolbar, and you can tone map to aces, which just adjusts the exposure and color of the scene a little bit. I'm not a colorist and I'm not going to touch aces, at least discussing that for a while, but I do recommend looking it up if you're interested in color theory. So we're going to leave aces. We're going to go Karma XPU perspective, and we're going to disable this correction toolbar. All right, keep going. Render settings here. Right now they set the resolution of our render, and there's also lots more settings which will set multiple things for actual rendering and actually how the regs are calculated in the bounce lighting, which is a more technical topic, but we'll get into it later. And now you can see actually right now, if we look up here, the render resolution that this is rendering at is just the resolution of what this current view is. So if we shrunk this a little bit and then refreshed it, sometimes with Karma XPU, you have to go to Vulkan again, and XPU, it'd be 548 by 685. If we make it bigger, go to Vulkan and refresh, it'll change again. It's not our current resolution, and the reason for that is we don't have this render settings selected. So Houdini knows nothing about what's going on below, just like we talked about in a previous example. So if we select that, we can go here, Vulkan, XPU, and it'll update correctly. There's the end. Awesome. So we just covered the first scene. Another thing you can do is if you go here, you can restart the render, but sometimes I've had issues with it not updating or updating every once in a while. So a good tip is to just go to Houdini VK Vulkan and select it. CPU is a little more consistent, and they pretty much render the same exact image, but you can look it up. There are some slight differences. All right, now we're going to pause and we're going to go to the next scene and explain what that one does. All right, so here we're in the first one, our project stage example V1. Disable the Vulkan, or go back to Vulkan to disable the rendering. U to go up, and let's jump into our second scene. Inside our LOPNet, example V2, we have a different scene, different setup, but accomplishes the same task, same goal. So let's reframe this a little bit. This creates the same render, and actually, I'll show you really quick. Go down here to the end, go perspective up again, Karma XPU. We'll render this, and now a really quick thing, and a cool thing we can do, is if you go to the left side here, we can add a snapshot. This little icon, we'll click the snapshot button. And I will pause by going to the Houdini Vulkan viewport. This is wireframe. Now we can hit W to go back, or this little icon at the top. We can choose between a bunch of different ones. So we're going to stick with smooth shaded. Hit U to go up. Jump into our project stage example V1. And now we can see this is a snapshot from our other example. What we can do is double click on the name, or click on the name, maybe you don't need to double click, and name it. Let's say example V2 render. Now what we'll do is select the node at the end with the display flag, go from perspective, Karma XPU, give it a few seconds to render. It might not render as quickly on your computer. I have 3 GPUs, so it might take a little bit longer, or Karma CPU may actually be quicker, but I don't think it would be quicker on your computer. We'll click snapshot again. Then we'll pause our render by going back to Vulkan. We can double click. Actually, let's rename this first to example v1 render. Double click it to open it. This will open an mplay view, which is a different thing for rendering and looking at images. We'll learn a little bit more about that later, but you can also look that up. Right click, color correction, because I like to look at aces, tone map to aces. And now if we can compare the two, very, very, very similar. Pretty much exactly the same, because they are copy and pasted but just rearranged. So they should be the exact same. Awesome. X this out and let's keep going. So I'm going to hit this snapshot thing again to close it down. You can open and close it. And let's get started looking at this one. The same way we worked with our last one, we created these empty primitive paths, which are stored here in our scene graph path. These are going to be the folders, essentially, that we're going to be putting everything in to organize. We create... Oh wait, we're still in the first shot. Let me go back. Go back to the second one, and I'll show you how the second one is a little bit different than this first one. So this one uses a lot of nodes and does a one-to-one relationship between the node and the task. But to save the nodes and to make it a little bit easier to work, we can kind of combine a few of them and do multiple operations in the same node. For example, this material library has all the materials, again A, and I can arrange them. And then I do all the material assignments with this same node here. Let's go back up and see how this one's set up. So the same idea, primitive paths, those are all set in our scene graph path, and those are all saved here. Then we add two SOP imports. Now, the different thing about this one is instead of creating this, so we can't dive into it, but if we did a SOP create, we could dive in here and edit stuff. But this is an import, and remember how we mentioned that example of importing the image from PowerPoint into Photoshop and creating it there? What we're now doing is we're importing from SOPs. And where in SOPs we're actually importing from, we can hit U to go up, our geometry container right here. So we'll double click this and look in here. And now here, instead of setting those all up, and the SOP creates, which I'll show you again, in our example one, instead of setting those all up inside these individual nodes and have them all by themselves, U again to go up, those are all created in the same one. This would make it easy if we want to do a big scene, or if it's just more efficient to work this way. This is typically what you would see, because you wouldn't really be creating everything in a SOP create. You'd be creating it here and then importing it in, or importing a full scene and then editing in a SOP create. So these are all our scenes, and then this is only a null, which is set here, so nothing shows when I hit U. So if I hit up, this output actually sets the display flag always to this null when we go up. So if I select this and view it, nothing shows here. If I disable this output flag, select the cube, U to go up. Looks like that doesn't, I'll delete the output flag then. All right, now the cube is there. Jump in. Now the sphere is there. U to go up. The sphere is there. Now this is just an empty null, so then if I had this accidentally selected and I had output, remember shake to disconnect because I had held shift accidentally. This is now always going to say display the output null, the empty null, which is nothing. So we never want to see anything through this container. So now remember what this looks like. We're going to go back with the U, up, jump into this one again. And now this SOP import, what this is saying is we want to reference, and where do we want to reference it? This is the exact node we want to reference, which is why we named it out wall. So if we click this little arrow, it'll jump and take us to where we were before. And now we can go back with this little back arrow to go where we were. And remember again, this jumps to where we were looking at. And then this back arrow takes us back. And the way these SOP paths work is just like a folder structure. So now we're going to select which context we want to grab from. We want the thing that's located in the object level. It's inside our props for the stage example 2. And now what we wanted to get was out wall. So we select that, And now we get wall. This is just a USD thing. If we save it, Control S and save our file, it'll go away. That's saying if we save our USD file and export it to disk, but we're not going to be doing that yet. So let's continue. So remember, G to frame. You might also have to hit space G to frame. F, space F. I guess sometimes it has to do that, but that's also a habit. Sometimes I usually do. So we'll go next to floor. W to hit wireframe, and we see this is a SOP import from our SOP path, which is here. We can look back again, and this is selecting this floor node, this null. Now we have all these other ones, which I won't jump into again. I'll just tell you how they're linked. This does the same thing. It merges the two and then graphs the branches, which merges this floor wall primitive to our background primitive. Same exact one, same exact structure as the last scene. Now we've got the cube, which imports our cube and names it based on OS operator string. So if we did cube new, this would name it cube new. But we just want cube. Again, this is a USD thing for saving the file, but we're not going to do that. So our Control S and saving your Houdini scene will clear it out. This merges everything back in that we've imported with our SOP imports. And then we graphed branches to merge it back onto props. Now our scene's slowly coming together. Again, W to set wireframe. Let's keep going. This is the material library we looked at earlier. It's all the materials set in a single network, and you can put as many of those as you'd like in here. U, those are now filled and brought up into our stage context by using this. So this is how we'll do it, and we'll set this up by ourselves later, so don't worry about this exactly. But what we can do is if we disable these, we'll see in our scene graph path that those are not being imported into stage. There might be situations where you have multiple versions of material. Say you want to do a backup or variation 2, but you want to keep this and not delete it, but you don't want it to clutter up your scene. In that case, if you had it here, you could just disable it and it wouldn't show up here in your scene graph. So jump back in here, I'm going to delete that. Q to go up, that's going to bring in this, and now this merge combines a bunch of them. The reason I have this here is because there might be multiple material libraries later, so this is just the way I like to work. You technically do not need this merge. Then graph branches will merge this scene graph, this primitive path, onto this one. Remember again, everything in our source prim path onto the prim path listed here, which is /materials. And the reason this is light or materials and materials again is because in our material library, when we define the material path here, it includes a prefix by default. So if we change that to material __, now that would be materials __. This is just the default one. It selects, and I've left it there, so didn't change that at all. Next, we assign these materials to all our objects using the same way we did last time. You can either type those out by doing /props props and selecting the one you want to do, which blue rough metal was our tube, or you can drag from here. So we did tube, and we can drag and drop it there. So if we wanted to set sphere, that'll have the sphere. Okay, and it looks like in this case is a good example actually maybe for me to show what's happening now. So it's assigning props /sphere, this material to the sphere, and then it's reassigning the rough orange material to the same sphere. So if I disable this, it should show our blue rough material on this orange sphere. There we go. So it's overriding what it just did there with this one. That's one thing to keep in mind. All right. What I now want to do is put the tube back in here, and we're going to continue. Again, this is an HDRI light, so a dome light. Again, we can show that with this little display light guides. Hit enter or escape to show and hide. All right, welcome back. This is a cut from future me. One thing to note, when we start looking at these lights and seeing how they're set up, we'll have these parameters up here again. And then one thing is if we hit enter on this node selected, while hovering over the scene view, this little gizmo will pop up that lets us move, transform, and rotate this. One thing to note is while we do have this gizmo up, we can middle mouse and pan to move around, but if we try to use our left click to orbit or our right click to zoom, that would not work. So in order to do that, we got to hold Alt to do so. So just a quick tip I forgot to mention, but good to know now. All right, escape again hides that. And let's keep going. These point lights are added in, named again, /lights/OS operator string, and that'll save this primitive under this lights and then named again operator string. So we can do point light right v2, and it will update that in the scene graph path. Gonna delete that and keep going. This again, graphed branches, is gonna merge these right nodes, these ones here under /lights. It's gonna merge actually everything on this right side because we've selected that here. And it's gonna merge that onto the lighting primitive path. So right here. Now if we continue again, we'll select this. We see these scenes, these toggle back in, and then we can also click this little icon to hide and show the lights. And then the next up, we've got the cameras, same setup as before, camera A, camera B, and camera C. And then to hide these is this icon right here. So A, B, C, we can see our three cameras, excuse me, and we can click in to this camera, select A, select B, and select C. One other tip actually to know is if you have a camera selected and we wanted to move the view while keeping the camera aligned with the view, we would just click this little lock, this turns red, and now if we move the camera, it's going to follow where we were. So if we exit this, it's going to go back to where we just moved it. Control Z to undo that, and then let's keep going. Again, our render settings here. This assigns what camera, so it tells Houdini what camera to look through. And we can see which one it's setting by doing render settings camera here. And then this will update. So whatever camera we have selected here will automatically update. So if we change this to camera B, we see we moved to camera B. Change it to camera C, we moved to camera C. Next up, got the end. This is a null we do not need. It's just there for organization. I'm going to put it back. Control Z and adds that back. This we'll cover in a little bit actually. It's how we save our render to disk. So if we wanted to export the file, we can click render to disk, which I'll also set up when we set the scene up, or we can render to mplay, which is the same window that opens up here. Again, to view that color in ACES, we can go down, right click, color correction, untone mapped, and go to ACES. And this is the results of the two scenes we just reviewed. Awesome, good progress. We're gonna get next into actually setting this up. But before we do that, we're gonna pause, come back, and then review a little bit about what we covered so far in the lesson and do a quick recap of everything we've got in this whole scene. So let's pause and I'll be back in just a second. Awesome. All right, welcome back. Before we review, I'm actually going to add in another one of these background images that I just put together on our roadmap of what we've learned so far. So we're going to go Tools, Edit Background Images. We're going to add this icon here, Create Background Image. Select Lesson 1 Lesson Roadmap, which also should be included in the files. Give it a second to load. Move this one here. We're going to create a new null. Place that right there. We can hide that because we don't need to see it. Again, click this little link. Drag and drop it, and then Tools, Edit Background Images, and we'll hide that up. All right, now that one was up here. Let's arrange it a little bit more, a little bit better, and let's actually resize it here to make it fit. So Tools, Edit Background Images, and we'll clean these up just a bit. Awesome, that looks good. So let's keep going. All right, so what we've covered so far is pretty much an introduction into everything we'll need to go into the next step. Control S to save, to actually set this up and set one of these stages up ourselves and implement our list of tasks. Again, the tasks that we're going to implement here in just 1 second is these. These ones right here are the ones we're going to be putting together, and we're going to set up a new network from scratch on pretty much implementing every single one of these one by one. So the first things we've covered so far is a general introduction to what Houdini is. Houdini, we learned we can think about as an operating system. So this operating system, actually I can't zoom in all the way, so I'm going to make it a little bit bigger. Tools, edit background images. And I'm lining this up so then this will go straight across. Tools, edit background images. Now we can zoom in a little bit more. All right, to continue, Houdini we learned is, or we can think of as an operating system. And on that operating system, we have different contexts. So these are the different programs we can use. We learned about an example where we can take a cube in one context, stage context, or Solaris, move it back to the object context to subdivide it or do some kind of operation, and then import it back into stage to render or continue working with. That was very similar as if we took a PowerPoint presentation, exported the image to Photoshop, and then imported it back into PowerPoint. So same idea of moving data between different types of applications and different contexts. And this is kind of the general way of how data is moved between the contexts. Next up, we learned about workflows, which is the sequence of steps that we take in order to complete this task here. We learned that a task oftentimes breaks into lots of small decisions, and these small decisions, when put together, would create a workflow. The workflows are split into two categories: destructive workflows, where everything you do is forgotten, and if you want to make a change, you have to go back, redo that, and then continue and redo everything past. The next type of workflows we learned about are procedural workflows, and our friend Houdini is one that works with procedural workflows. One quick note is actually workflows are not always procedural in Houdini. You can set up destructive workflows, but the way we're going to be working was with the intention of keeping workflows procedural. Next up, we learned step 3, our framework, 1, 2, 3, of defining our goal, breaking it down, and then implementing. So we took our reference image here, we defined our goal of recreating the reference image, we broke that down into tasks and chunks, our background props, material, lights, camera, render settings, and then we broke those down further into the individual tasks, the actionable tasks, and single actionable items that we actually will implement. We then continued to organize these tasks and assign these, and we learned about how Houdini works through and goes through our network to actually complete these. We learned about the 2 rules that Houdini has. There's more, but these are the 2 ones now. Rule 1, Houdini can only move down the graph, can't go up. And then rule 2, Houdini can only see and only operate on the information that is above it in the graph. So anything, if Houdini was right here, it can't operate on anything below. And then we also learned that the same task, same goal, can be implemented with different networks. And these might have a different structure, different organization, and it's up for you to decide how you'd like to organize your network and how you can accomplish your goal. Next up, we talked about Solaris, Stage, and USD, which was the context right up here. Right now we're in the geometry, the object context. We jump inside here, now we're in Solaris, the stage context. Another way we can access the stage context, remember, we can go up here, OBJ, we can select stage. This takes us into the same context, but for me, the way I like to work is inside these LOP networks. So go back again. Whoops, not the out one, the OBJ. Give it a second. These LOP networks are ways we can organize and structure different stage information, and we can keep as many of these as we'd like. These also can go inside geometry containers. So if we did a LOP network, again, wait for a second, we could have them here if we did want to, but we're going to keep them up here at the object level. Next up, we learned about USD, what it is. It's the technology invented by Pixar, and Solaris is built on top of USD. So the framework of USD is implemented in Solaris. Then we learn about primitives, which are the names and the representation of everything in USD. We learned that materials are primitives, cameras are primitives, and objects are primitives. We learned that those primitives are stored and listed out here in our scene graph. And then all primitives here need to have a unique path. So you can't have two primitives with the same path and same location. They have to be unique. That'll come actually, if we use that, we can leverage that in order to intentionally override primitives, which is another cool thing we can do. So we learned about these LOP networks is where we're going to be working. And then the next thing we did was we actually opened up Houdini and jumped into interacting and moving nodes. So we learned how to drag and drop nodes, how to hit tab. Tab you can search, so node name. We did geometry. And then when you create these nodes, the ones you see when you hit tab are the only nodes that are relevant to the context you're in. So if we try to create box here, it wouldn't create a box. It would actually, we'll see in a second. It'll create a geometry object, a geometry container, and then inside that will be a box. Now if we create a box here, it'll create the actual node. One other thing is we cannot create nodes that are relevant to one context in a different context. So if we jumped inside our LOP network and we try to create a box, oh, well in that case we can't. But for example, if we wanted to add a light here, the lights don't show up. So the stage, the Solaris lights that we were using, don't show up in the geometry context. That'll be important later. So if we're in materials, we'll be able to see material X node, which was this one. We'll put a material network, and inside we'll be able to do that. This is the different way of working in Houdini. We're not going to be using this because we use material libraries in our LOP nets in Solaris. So again, our materials that we'll be using are stored inside here. Next, we saw how we could color nodes. So we could change the color of those nodes by pressing C. You can also press Z to change the shape. We learned how to add sticky notes. Node here. And then we also learned how to do these images. So that's another workflow tip if you want to have a reference image or some kind of really anything you want to see. In this case, I made these note slides that we've been reviewing and working out of. Next up, we saw our two implementations. So our project stage example V1 and our project stage example V2. These were two implementations of the same network, or excuse me, same goal implemented in different networks. And remember how we learned that the same goal can be done in different ways, and that's up for you to decide. Hit U to go up. Again, this is a slightly different network arrangement. We can actually arrange these in any order, and we'll see maybe in the next time about why you might choose to do some one way and why you might do them the other way. And now we're here. So one way I kind of like to think about this is how a chef works with pots and pans in a kitchen to create delicious food. We will work in LOPs, or excuse me, we will work with LOPs in Solaris to create our delicious renders. So let's get started, and we'll pause again, and then the next step, we'll create our own LOP network, create a new geometry container, and then we'll recreate all of this from scratch. And you would be able to do that in an empty file, but just to keep it consistent. And then if we do want to reference back one of the things we saw before, we'll be able to do that in the same file here. So let's pause and come back in just a second. All right, quick note from future me again. Before we actually start implementing this, I did notice when I was rewatching these videos that there was one quick thing that popped up that you might actually have a question on. So let's jump inside our geometry container again. When I added that node from Solaris, the light node, what I did notice, hit U to go up again, is that in here, if I type light, I get a few things here. I get cloud lightning, labs lightning, and then two of these nodes, which you most likely, actually you definitely will not have. These are HDAs. So right now you'll probably only see cloud light. And the reason you don't see labs lightning, if you type in labs, you might have side effects labs installed. But if I type in labs, I'll see all these extra nodes. Side Effects Labs is a collection of HDAs that the developers of Houdini Side Effects have put together, and they're super, super helpful. I highly recommend looking into them. Right up here, there's labs, and this is what you get when you install Side Effects Labs. So I won't cover that, and I will not cover HDAs yet, because those kind of are a rabbit hole we're not going to jump into. But if there's any nodes that I type in, so here example are some of my other HDAs, which we probably won't cover yet, but eventually we might be making our own. Those would be the names that pop up here. So we'll cover in doing those, but not yet, but I just wanted to drop that as a quick note in case you were curious about what that was. All right, so pause again, and we're going to come back and implement the network from scratch. So we're going to do it ourselves, and we're going to create a similar scene and maybe even do a few extra stuff just for fun. So be right back. All right, welcome back. We're going to start implementing our network now from scratch to recreate this shot. But before we do, I'm actually going to show you how to render these images out and save them to disk. So what we're going to do is we're going to render this out, save it, import it back as one of these background images, which I just did while the video was paused. I'm going to delete this. This is what happens in a background image. It was deleted from disk, or the file path was changed. So delete that. We're going to render it out, import it back, and then we're going to use that as our reference to recreate it. So hit U to go up, jump into this one. And now the two ways you can actually render out an image are you can double click this snapshot window here. So click this, open again, double click the image. This will open an mplay window. We can right click, color correction. Again, I like to look at aces. You can look up aces, but we're not going to cover that. That's more into color theory and color science, but I'm not a colorist, so I'm going to skip that for now. So we could save here, save frame. This now is the hip location. So this is the variable in Houdini that stores the current location on disk where our Houdini file is saved. You can see up here in the file path, this is where on disk my actual file is saved, but yours will be a little bit different. So we're going to type out the file we want to save and the path we want to save it to. So we're going to save it in our current hip file, our current location where the hip file is saved. We're going to save it in another folder, render, and we're going to name our render. Let's say this snapshot, save, and we'll do PNG. So you also have to type out the file format you'd like to save as. We'll say our first render. Our first render. Snapshot save.png. Now we're also going to do in color space, we're going to select bake to open color IO display view. What that's going to do is that's going to save this aces transform that we just set up here, and when we save it to disk, that's going to bake that into the file. Now this color in this alpha, this is the channel in Houdini, an image that we'd like to save. In this case, C is our beauty render, which is just the render we're seeing now, but there's also other AOVs, which are render passes that you can save in Houdini and do specific things with. We might cover those later, but we're not going to cover those yet. So we just want the C, the beauty render, and we're going to double check everything is correct and then save our image. Now we can close this out, and if we did want to load in, so I'm going to hit this background image again, and now you see in our hip file, hip location, we have render. This is the new folder that we just created. We'll open that up by double clicking, and now we can see our render snapshot. We go to tools, edit background images, we can click, and then let's add a null. We'll do this again once we have our other image in the different LOPNet. This again is our LOPNet, our project stage example v1. U to go up. This is the other LOPNet. We're going to create our own new one. So jump back into this one. Tools, edit background images. There we go. The other way we can save files is using this. This is a USD render ROP. A ROP is a render output, and it's how Houdini saves files to disk. So instead of maybe in Blender or other files, other softwares, you do file save as or file export. Here you see we can't export, at least in this case, we can't export the image that we'd like to save, and Houdini exports geometry also with ROPs. You'd use a geometry ROP. This ROP is going to save our file to a location that's been specified by this node, our Karma render settings. So if we select this, we can see it's going to save it to hip render, my first render, and this is the name it's currently set as. But let's see where this one was saved. So if we open this again, so hip/render, we can copy. This is our first render snapshot save. Let's do paste. Let's do our second. You see, this shows up. That's the file we just saved. If we selected this, this would override the file we just created. So we're going to do our second render. Our second render snapshot save. And now the resolution, the camera here is selected. We can also select a different camera. In this case, this is set to render settings camera, so it automatically updated. And the reason it's automatically updating again is because we've selected a node down here. So this end node knows what happens about our Karma render settings. But if we had this display flag, the blue flag, set above here and we change this, it would not update this one here. Again, that's render settings camera. So again, we're going to select this end, select our Karma render settings, and we see the resolution we're saving it at, and then also XPU, which is the render engine we're using. We're using XPU, which again is selected up here. Karma CPU also can render, but it's a little bit slower. So we're going to use XPU because that uses the GPU. This is just the samples, so the quality of render we'll have. 128 is fine for this example. And then I also have, I'm just showing these different settings, which we can get into later, a denoiser set. So you can do no denoiser, or you can use denoiser, and it's going to denoise this AOV, this arbitrary output variable. Or value. Sometimes people call them arbitrary output values, depending on your software. All right, so if we saved this, we can double check the file we're saving it to. Render our second render, snapshot save. Click render to disk. One more thing actually before we render to disk, this is the timeline down here. If you just drop in a render ROP, what it's going to do, the default, actually not render ROP, Karma render settings, again, because remember Karma render settings is what chooses and what defines our file path that we're saving to. Give it a second to load. We'll see this. This is $hip, which means current folder our Houdini file is stored, /render. Hip name is the current name of our Houdini file. .os is operator string, so the name of this node. And then $F4 is a 4-integer padded frame number. So 52 would be 0052. If we did 27, all right, you can't start. That's another thing we'll learn. You can't name a node with numbers at the start. Yeah, so Houdini will warn you if you do that. But so 0027 would be the frame we're currently on. So you can do that, that's fine. And if we render this 0001, again, we can't do that because of the numbers, but that would save it as that frame. So if we're doing animation, we want 4-digit padded integers. So I'm going to delete that. Give it a second, delete this next one. All right, save our render. Again here, and actually what I could show you, $F4, this is going to pad it to 1, but let's jump ahead to 23. And we don't have any animation done here, so nothing in our view is going to change. But if you did have animation, it would show up here. Let's do 23. And let's render. All right, it rendered. Sometimes it pops up with a little progress window, sometimes it doesn't. I'll try to figure out why, but maybe it's recording, so it's not doing that. But let's go up here. This is the first render we did. Click this again. Open render again, and it looks like it's still rendering. So let's give it a second and see if it was rendering, and it's going to come back up in a minute. There we go. So we just gave it a second. It looks like it was rendering in the background. And now our second render _ snapshot saved 0023. So that was the one we just saved, padded with 4 zeros. Again, remember how we mentioned 00023 is the frame we're on, and it saved that. It might take a little bit longer to render on your computer. The render time is going to be defined by your hardware, your GPUs, your computer, your resolution, and your samples. So how quality, what the quality of render you'd like to do. So if we put this really low, it might render quicker. If we put it really high, it'll take a long time to render. Awesome. So we've got these two now. I'm going to delete this one, and then let's jump into our network. We're going to create a new one, and we're just going to import that in and then create it from scratch. So I'm going to do tools, disable that. Click that again, it takes me up. I'm going to save and then create our new LOP network. Let's do our project stage example v3. Follow along. And then geometry. Whoops, not that one. That rubber toy, actually, if I do rubber, that's test geometry in Houdini. You'll see that a lot if you look at Houdini renders online. That's just sample geometry that's been included for you to do tests on. We're going to name this as our props for follow along. Awesome. And now to keep a little bit extra organized, what we can do, let's add this one right here, which is a network box. And we're going to drag, we'll add here, and then we'll put the new nodes we just made in this network box. So we'll call this follow along, sure. Now we're going to color this a dark one just to hide it. You can color it anything you'd like. And then we are going to get started. So jump inside our LOP network. Now we're in the Solaris context again. So to get started, the first thing I'm going to do, I'm going to add a null. We're going to name it start. And then the color of the null right now, yours probably is not going to be black. So if I drop a null, it's automatically black. The reason that is because I've colored these to be black by default. So if you want to change the color they are by default, you can hold down Control and then click the color and drag it. And now it will change all the nulls to that color. And also if I added a new null, there we go, now it's green. Let's make them white. Select those both and made them white. And let's name this end. We'll do uppercase. And now again, A, and we can do this to arrange our nodes. But we'll do start and end. And now we're going to connect these and add some extra stuff. But let's get that reference in. So these are the renders we just made, remember? Hip. Also this again, if you are not following along yet, this is the part of the lesson where I'd encourage you to follow along. So we'll go hip / render and then select. Let's do this one. Tools, edit background image. Actually, let's load the other one and see what it looks like. A little bit bigger, that's because we're zoomed out when we added it in. And then we'll make this smaller. And then tools, there we go. All right, they look different. And remember, the reason they look different is because when we saved our image, the snapshot only actually shows your current LOPnet. So if I go U up, when we saved our image from the snapshot here, we right-clicked and we saved our view transform here into our file. When we saved it from our USD render wrap, we did not do that. So U to go up, jump inside here. This one we saved with aces. This one we did not. Now aces lets us do lots of things, but it pretty much lets us use a wider exposure bracket, lets us have better brights, better lows, or highlights, shadows, and then also better color for things like explosions or fire. You might want to use aces. I won't cover that, but you definitely can look it up. All right, X, close that out. We're going to add a null. We're going to name this. Remember how they were all green? Let's change this actually. Control, drag, or color. Looks like we can't do that while we have that selected. So first, I'll actually connect this with the link. Tools, edit background images. I'm going to control, change them all back to white. And now if we rename this, let's say our reference, it's going to mess up where our image was. That's just because we renamed the node. So let's relink it again. Awesome. All right, let's get started. First step we're going to do is get started on our background. But before we do that, remember how we had some primitives to define. We're going to set up those primitives, which are going to be the folder structure that we create and added everything into. So we'll start with primitive. Whoops, excuse me. Primitive. This primitive node lets us do a few things, but we're going to use it for right now defining the primitives we're going to be starting with. Now you can see $OS, operator string, primitive 1, loads it down here in our scene graph path. If we set this as our new prim, we'll see it's right here. Within this primitive path node, we can also do these slashes to make subfolders or update the hierarchy here. So if we do os/a/b, we'll see our new prim path, $OS, operator string, open it up, A right here, B, and then B. And then if we did again, $OS/a/ let's say C. Now it adds it under here, A. We can also add as many as we'd like. So say we did $OS/ let's do background maybe. We're adding a lot of things, or we could do $OS/props/ hero props maybe, /$OS. Let's say secondary props. Maybe we could do $OS props, and maybe we have a wall or a background. Maybe we have a, I don't know, sphere. That will show, and again, we have this node selected, so we see those. If we drag and select the start, it's not going to show those. We'll select this one. Now we'll have all those extra things we added. These you can organize however you'd like, but we're going to delete that. And then we're going to start and we're going to create these. So we're going to do /background. /props, /materials, /lights, and then camera. Another thing when we add, and we'll see later, materials, by default, sometimes these will be added already to materials. So if we continue to link these, it might be stacked under materials. We could do that however we'd like. We could say our materials. So let's actually do that. We'll change it a little bit. Our props. Awesome. Now we got the start. Select this one. Now we see what we have here. So we just defined right up here, this little thing. This was the start. We defined our new primitives, which we're going to store everything on. And now let's start implementing the tasks. Step 1, add background floor. Now remember how we started that with a SOP import. We can either do a SOP create to create it inside here, or we could do a SOP import and create it somewhere else. SOP import lets us select the SOP path we'd like to use. So since we know we're going to be doing a lot of things, background props, looks like these actually is the only geometry we're going to make. So let's jump into a geometry container at the object level to create our new props, and then we'll come back here to add them in and get them set up. So obj up, right here, geometry, our props are following along. Jump inside here. Let's do a floor, a wall, cube, sphere, sphere, and tube. So cube. Give it a second. It's a box. They sometimes rename nodes differently. So you see box, cube. It's the same node. Side effects, Houdini developers have just renamed those because you might be typing whatever you'd like to type in. So box there, we're going to do a null, which is how, remember, we're going to reference from our SOP get, or our import SOP import. So when we do our SOP import, also look like this one again. If I hit P, that'll pop up the parameter panel, which lets us hover over this network view. You can work there. It's the same thing again here. P again hides this. And O will show this little network overview here. So it shows us where in the network we are. This is helpful if your scene gets big, and you can just have this on if you'd like. So O again, and P for primitive. So again, our SOP import lets us import geometry from SOPs, import it from the different context. I'll leave that there. And where are we going to import it from? We want to import it from our geometry container and box. So we're going to name this easily so we can find it. Let's say box. Let's do out. Out is just commonly used because then when you search it up, all the out nodes that you want to select are right next to each other, and they're in uppercase, so they're easier to read. So out, we'll do this our box. Great. Now, if we wanted to get this above on the floor, what we can do is we can see the box right now is 1 by 1 by 1. So you see zeros in the center, half. So half a unit, negative 0.5, and this is that geometry spreadsheet we talked about. So we can either transform and move it up. Now, one more thing again, you see, drag it up and hit enter to get that, escape to hide it, enter to get it. One more thing here in SOPs, these nodes by default operate on everything in the stream. So different from how USD operates where we have to select the primitive, SOPs here will operate on everything. There's ways we can choose what we operate on. This group here is one way. So you can select and choose different things. In this case, I have different faces or primitives here selected. You see select primitives. We're not going to do that, so I'm going to hit escape. You can set these groups, modify certain parts of groups, and you can also define groups in different ways, which we'll cover later. Or if you want to look up procedural modeling or SOPs tutorials, all of those are relevant here. So we're not going to cover those today, but you're welcome to. So out our prop box, and we're going to move this up. Let's move it by 0.5 along the Y. Awesome. Let's do a bevel, which again rounds the corners, rounds the edges of this geometry. And the distance here is how much it's going to round it by. Let's do 0.01. Now you can see right here, this is some normal artifacts. This is the faces. The primitives of this geometry are having shading issues with normals. So we can increase our divisions, 5, which is going to increase the rounding. We can also recompute normals. Normals you can see here. They're vectors in our geometry that defines the direction that a face or point is facing. In some sense. You can do other things with normals, but we're not going to cover those. You can compute normals, for example, here on objects. And you can compute the data on points, vertices, or different areas of the mesh, which again here in our geometry spreadsheet, this is points, vertices, primitives, and detail. We're not covering those yet, but you can look at other tutorials to do that, or we might cover those later. So all we need to know, box, transform, we move it up. Remember, this is the template flag. It lets us see a wireframe, a preview of what we have. We select it, we bevel it, and then we have our box. Select everything A, awesome. Check 1, which I guess we started with box, so let's go sphere. Sphere, we're going to load it in. Again, the template flag's here, we're going to hide that. Select template flag here, you can disable it and enable it. We're going to do Alt drag this, duplicate the node. We'll name this out. Our space is going to do an underscore. You can't have nodes that have you can't have spaces, so it automatically has an underscore. We're going to do out our sphere. Awesome. Now what we can do is we can subdivide. To smooth this, we'll add a little extra resolution. We can hit W to show wireframe, and if we wanted to hide these lines, we can go up here, smooth shading, and that'll hide those. I'll leave them on, but you can turn them off if you want. Select everything A. There we go. We can also, in this one, we can select frequency. I guess in this one you don't have frequency, but if we disabled this, you can change rows and columns, which is how big or how many rows and columns the shape has when it's created. So we'll leave it at the default of 12 and 24, or you could do 36. You can do whatever you want. We can subdivide this by unchecking this bypass flag, which enables the node again. Go down out our sphere, and we have our sphere. Now we'll do another sphere, but maybe let's make it smaller. So we can either do here, select the sphere, uniform scale, or what we can do is do a transform, and we can affect the scale here. So put that here, 0.5, maybe make it smaller, or 2, make it bigger. One other note, these nodes, these wires, you can hit Shift S to change the way they are drawn. Either way works fine, but some people you might see have this, and you can just choose which one you like more. All right, this is our node, our sphere now. Let's do sphere small, and we'll make sure this is smaller. So we can template that flag here to see the sphere we just created in this geometry stream. And now if we want to compare it, we can hit the display flag here. This now is showing this node right here. We can maybe make it smaller. All right, so now it's a good bit smaller. Set that one here. We can hide this again by unchecking this display flag. Now shift or select everything and then hold down A. We can drag and arrange those. Now let's add a tube. This here is a tube, another default shape in Houdini. These are used for lots of other things too, and you can do cool effects with them, but we're just going to use them as the base shapes here. So our tube we're going to add, we want a top and a bottom here, so we're going to check end caps. The other thing here, these blue artifacts, this isn't artifacts necessarily, this is the shading in our viewport, in our scene view, that shows the direction the normals are facing. So this is the back side of a face, or back side of our primitive, and this is the front. If we did a reverse, it'll reverse the normals on our geometry. Again, that's just why it's blue. All right, end caps, we'll check. Radius is the size. So again, middle mouse, you can select and drag to make it bigger and smaller. We'll leave it at 0.5. Scale the radius maybe to 0.25, and let's make it 1.25 in height. And now what we can do is our poly bevel again, and we'll see a new thing on this poly bevel node. So again, A, if we want to move these around, a new thing on the poly bevel node is when we start to bevel, we'll notice it bevels everything. So if I do 0.01, it's going to bevel every single side. What we can do is we can choose exclusions, ignore flat edges, which is going to look at the normals of our objects, maximum normal angle, and it's going to only bevel faces that are with certain normals. So we'll show you in a second right here, but if we select tube, let's add some more. I'm going to select again the tube here, and we're going to add more columns. So show it here. Instead of 12, if we had 60. So now we're adding more resolution along the vertical side here of the cube. Now if we select poly bevel, it'll bevel still the same things. I'm going to add more divisions, 3. And now it will bevel, actually that's not a good example because, all right, here we go. So I made it smaller, so now we can see it bevels everything. If we don't want to bevel these ones with similar normals, we're going to ignore flat edges. So it's going to ignore normals that have a certain distance in the normal between them. So the difference in normal between these ones, we can check here, see the vertex normals, this is what they are now. But this shows normals, we'll also get into this later. But if we increase the maximum normal angle, what's going to happen is it's going to say any normals that are similar enough, we're just going to not round those. And now you see, low, we round every corner, a little bit higher, we hide those, and we ignore those because we want them to be not beveled. All right, annul again, drop down, add that in. We'll call this out our tube. Select everything A and drag. All right, now we got our cube done. Our sphere, remember space G, sometimes we have to hit space F to frame without moving the camera. So space G here. We've got our cube, our sphere. That's my dog barking in the background, excuse that. Our sphere, again, the smaller one, and now tube. Another thing if we wanted to do, if we wanted to move this up, We can do a transform again. Drag to drop that. You can shake to remove. Transform. 0.5. We'll put it there. We can also use a match size node. Match axis and match size again. It's the same thing that happened with that box. Actually, it looks like they are different nodes. So excuse that thing. Ignore that what I just said. Match size. And now if we wanted to justify the minimum Y, we can do that as well. We can also do that with X. Max. Leave that on center. And now we just lifted that up to the floor, to the world origin. All right, Alt drag to copy that. We'll do that again here. And let's do the same thing, why not, for the cube or the tube. Awesome. Delete this one here. All right, now we've added these all. So let's go back to our LopNet and we'll start importing these in. Actually, what we could do is create the background while we're here. So I'll do grid. Select the display flag. Alt again. Sometimes you have to hit Alt. Right click to zoom in and out. Middle mouse to pan. And then left click to orbit, to rotate. Select our grid, and that's going to be fine. And actually what we can do is we can use the same geometry for the wall and the floor, and that's going to let me show you a different thing in USD later. So I'm going to leave that the same. And we'll say out grid. So we'll change this to both floor and the wall. So I'm going to use the grid now, and then we'll import that into Solaris, into stage, and use our lops to arrange that. All right, inside our LopNet, let's start with, let's add that floor and the wall first. So I'll do add wall. We can go here again, slash obj, follow along, which is the geometry object. Actually, that is our stage. We want this. Our props for the stage example 2. And now we'll see the ones we all just made. The ones we just made and we want to import floor wall, it looks like U to go up. All right, it looks like this actually was from the previous part of the lesson. So our props are following along is what we want to be referencing. So jump back in here again. You can also click this button and that'll let us drop down and select this. So let's say following along, grid, accept. This will now import our SOP, our objects, our geometry from SOPs into stage. There we go. This also says $OS. This is the primitive path where it's going to be saving this in our scene graph. Now, what we need to show is we need to move this and then also set up the back wall. Transform. Oops. Transform here. Select this. Connect the two. Again, Control Save will get rid of that warning there. Transform, and now it's going to transform. Right, this now is just set to the last primitive, I think, in the network that was modified above. We're going to delete this expression, and we're going to name /wall. Now, if we move this, it's not going to move. The transform will, but our geometry, our object, our primitive will not. The reason for that is because this is named add wall. This OS, $OS operator string is setting that name in our scene graph path. We want to rename this to wall, and then we're going to be able to move wall. So select here, we rename our node to wall. Great. Now that worked. Let's say we wanted to keep this exactly where it was, but maybe move it along the Z. We'll move it 1 unit. Now another node, which we'll see, and another thing in Houdini actually is if I did a duplicate of this, you'll notice if I copy this, this would change the name, wall 1. Now, you see this is wall 1, and when it loads it back in, it's a different name, so $OS, now it's wall 1. If we wanted to use the same transform primitives on this new node, so shake to disconnect, it won't work. The reason for that is because we're trying to move wall, but our primitive is named wall 1. The ways we can either do that is hit the asterisk wildcard, which will let us move wall or anything named with wall after, so drag and it'll move. Or what we can do is we can rename, so say we did want this to be wall. We can rename this and delete this expression, delete channels. All right, looks like we can actually just select and delete. You might not be able to delete. Remember, middle mouse lets you see what this evaluates to. So if I delete this, it doesn't actually delete it. Delete, enter. I have to select it, see what this actual expression was typed in, and now wall. And now it's saved as wall, and this is also saved as wall. Now this is a good case to show you a thing of USD, which we did mention, that USD primitives must be named uniquely. So say we have this transform, we move it there, and now say we wanted to do the same thing on this wall, and let's rotate this. So I'm going to zero this back out, and let's rotate. Now, say we wanted to merge these two. If we did try to do that, what happened? So what just happened here is we had wall, we moved wall, it's named, remember, scene graph path, wall, and we have another one that's also named wall. We did move this one as well. We moved wall, or everything named wall, so we changed wall, super wall. Same name here in SOPs, or excuse me, SOP import, the operator string name was changed, but it's still saving as wall here. It gets moved, and now when we select this display flag, what happened is this new part, this new primitive, overwrote this primitive right here. So if we change this to, let's say, wall 2, you see it comes back. So this is wall 2, and this is wall. And when they're merged, they're not the same primitive. So let's change it back to wall. We'll keep this one as wall. And now we can do another thing in Houdini. We can hit Shift R, which will reverse the nodes here input. So Shift R is the order they're being merged. And now you can see if we have this one on the left and this one on the right one overrides what's on the left one. Shift R. Now this is on the left, and this is going to be overwritten by this one. See, right here and here. This merge in the order which they're merged, in this case, does matter. In other contexts in Houdini, such as in dynamics and simulations, the merge does matter, but in SOPs, it does not matter. At least for what we'll be doing, it does not matter. All right, so let's keep going. I'm going to hit Y again to cut these, and then I can reconnect them. So A, organize, A, to arrange, wall, transform. Let's put this back where it was, 0. Now this one we wanted to actually create the floor with one and the wall with the other. So I'm going to leave this as wall. We'll move this maybe 1 unit on Z. This can be our floor. So remember how we have the same out grid? We reference the same geometry from SOPs. Again, we can click here, this little arrow. It'll jump to where in SOPs, where in our geometry context we have this stored. Now if we go up, it'll take us back into, 1 second here, the object level. But if we go back inside where we were, our LOP network, and here, if we jump in here, these arrows at the top can take us back. So back to wherever we jumped from. There we go. This is where we came from. So now let's set this up as our, this is our wall. Let's do, this I guess is our floor. So let's leave this as our wall. So to rotate this, we can add that as a wall. So we can click again, enter to get that showing. Control also, if you hold, you can lock these to transform into certain degrees. We'll do 90, and let's move that up. So I'll move that up 5, maybe leave that at 0. This is our wall. Now let's do our floor. So if we wanted to name this floor, we could either do floor and then reset this back to $OS. Now if we select this, our primitive is now named floor, but we can also just do floor. Now if we said this is our floor, you see the name is not reflected here in the primitive. Great. So let's merge that again and see what we have. Now let's move this. Remember, wall, you see floor, so it won't be moving this. So if we move this transform, nothing happens again because our primitive has not been selected. So we'll do here, we can do floor. Let's move this 2.5. All right, looks like 4, let's do 5. All right, now this is good. This is the great setup. A, arrange. And let's color these the same way that they're colored here. Let's color them red. Again, C to open and close this. Awesome. Another thing you can do is hit L, and then Houdini will automatically arrange the nodes. Control Z to undo, L to arrange. Sometimes this works, and sometimes if I selected everything, L, it might not be the order I want it. So sometimes it's better to do either select a few and hit L, or arrange them manually, or even just do this A and drag around. So you can hit L again, and it'll automatically arrange them. Let's name this our background. Great. Now we have our floor and our wall, and let's merge it in. So now we see our primitives. We select this one again, and this is our outline that we've defined. So if we do a graphed branches, which will let us merge these two branches, we want to merge it onto here, input stage. Again, everything in USD is a stage. That's the framework of USD. Every output of every node is a stage. But for us, all we need to know is left in here, right in here. Now, we select what we want to do, in this case, the right, and we want to merge it, not on this, which is default by the last prim modified. We're going to delete that, and we're going to manually select. Now, you see all these pop up. Layers we're not going to get into yet, but that's another USD thing. All these pop up, and we say our background. So now we're merging. This is also another display flag, which you can look up, but we're not going to cover. This one here, not a display flag, excuse me, a node flag. Now we're merging everything on this side with the left side. We can see if we open up our background, there we go. Let's connect this and let's keep going. Let's say combine or add background. Perfect. Next, we're going to keep going, and we're going to add in our props. So remember how we created all those props? We're going to do a SOP import, again, to fetch geometry, fetch data from our other context. A perfectly valid way to do this would also be, again, O, to hide and show that, a SOP create, which would let us create it right here inside our LOPNet, which you don't need to do that yet. I'm going to delete the SOP create, and let's say add cube, and we'll go here, select our props for follow along. We'll do box, space G, I just did. Save it. Perfect. Now we'll do alt drag to move, add cube 1. That's what it renames to. Remember, it's going to rename that in our scene graph. Let's do out box. Let's do sphere. Alt drag again. We're going to rename these later, don't worry. And sphere small, and then let's do a tube. I'm going to move this again. See, we're just recreating here the tasks we have created, and also the things we'll see here. We can even copy this camera later once we get into that. So cube, we wanted this to be our tube. Arrow keys, sometimes it does load those, sometimes it doesn't. And remember, it's not sphere, actually, it is tube. So arrow keys up and down we can do, enter, we can hit select. There's our tube. So let's rename this to box. This is our big sphere. Small sphere. And tube. A, arrange if you want. Save. And now we have all of these, and let's arrange them. So we can do merge to see where they are. Now everything's here. If we want to transform, let's arrange them in the same way we have here. So this big box, let's actually see where it is. So before, if we want to see where our background is, what we should do is we should merge these together with another graph branches. And then we can set our display flag, again, Y to cut, on this graph branches. Looks like there's a typo here. Add, let's say, props. Now we want to merge everything here on the right with our props, or onto the primitive, our props. Ta-da, there we go. Now we have those set up, but we do want to move them, so we can transform, select here. What do we want to transform? We want to transform box. We want to move it a little bit out. Let's see where our image reference looks like it was here. Another thing we could do is, since these are separate, we can jump back inside this network. Same network we have right here. If you notice, if we move this node, it'll move it here. We could zoom in here just so we always have this visible. Perfectly fun to do. But I'm actually going to go back U to keep our tasks here, just so we can remember what those were. And also, this is the node graph, remember, we set up earlier in the video, and we learned kind of how Houdini walks through this. So we add our props, transform sphere. We can alt drag. It won't transform the sphere yet, so we can change that to slash everything, which will move the sphere. There might be some flags that pop up later if we do transform everything, because remember, materials are primitives, and transforming a material in the 3D space doesn't really make sense, so it would show a warning saying that these primitives are not able to be transformed. So we're going to transform our sphere. Big sphere, it looks like it's called. Now we're going to see here, we can see what they look like merged together, or we can select this one here. So now we can also select this, escape to hide that, select that one, and we're just going to transform this sphere. Looks like it's a little smaller, so we could do that with our, you can do that in SOPs if we did want to make that smaller, or in this transform right here, 0.5. Let's just make it a little smaller. Looks like our cube actually is rotated too, so I'm going to do that. Transform, rotate, again, escape. We'll hide that, select the transform, enter to show it again. Let's put that at 45. This cube, or this sphere, is right around here. Perfect. Now let's do the second sphere. We add that in, import again from SOPs into stage, transform, small sphere, set our display flag down here, and move this here. And then Alt. Remember, sometimes you have to hit Alt, especially when this widget is visible. We're going to put that right here. And you might be thinking this is a little bit tedious for such a simple scene, and it is. But once scenes get more complex and we have cities or very, very, very large scenes, this way of working is easier to stay organized. And there's also things we can do later that will kind of save us from some of these tedious tasks that we're doing right now. So we add our sphere. Let's do a tube. So transform. We're going to take this primitive, this SOP path, which is being fetched again from SOPs from our geometry context, connect it to transform, and we're going to move not what this is, not this expression. We're going to move our tube. Now, if we click and drag and drop that here, it'll automatically add that node. Click and drag and drop, shake to release, and then Y again to cut. Display flag set here. You can see our scene is slowly coming together. Enter to select this transform gizmo, move it, and we need to, oops, I did it again. We need to set this tube there. So what we're going to do is we're going to scale it down again, 0.5. We can move it. These little squares will move it along the axes that are perpendicular. So red will move it on everything except red. You see, everything except the X. This will move it on everything except the Z. Everything except the Y is this one right here. So that's a quick tip to know if you wanted to, for example, put it on, line it with the floor, and you were in this camera view and you wanted to move it, but wanted to make sure it did not move in Y, you can select this one and it'll move everywhere except Y. Quick little tip there. All right, let's reset this back. Remember, you click 0, 0, 0, also tab. If you hit that, it'll go to the next box. Shift tab also goes back. So I might be doing that. Shift tab, that's just a quick way. Shift tab, remember 0. Shift tab will go back, and tab will go forward. So let's move this here, and let's rotate this. Another thing here is we can do a pivot transform, which will change where on our object our pivot is, our center here. We're not going to worry about that yet, but we're just going to set this here. All right, a quick cut here. I actually wanted to mention one more thing about this handle that I forgot to mention earlier. When we select the handle, so say we have this transform here selected, it's on our tube again, we hit enter with our transform here selected, it'll show up this little handle, this icon. We can move everything here, and the other thing we can do is hit Y on our keyboard to switch between these handles. So this right here, you can select everything. This one is for scale. If you want to scale it, you can hit Y again. It'll go to these different ones, and you can change those. You can also hit M on the keyboard, which will change the orientation. So right now, this is aligned to the object. We can align it to the world if we wanted to move it here. But if we wanted to say slide this tube right up in this direction, we can hit M, rotate through until we get one that aligns with our actual object. All right, great. One more tip I actually just didn't want to mention was that one. So let's keep going, and we will position this again, similar to how this one's set up. So we're going to lean it right against this front cube. So enter, move it down. And this is another case, you see, hit that M key, and now we can move it in the world space, so the world directions. There's other ways of arranging objects in Stage in Solaris that we'll cover later, but for now, this is a fine way for us to do it. All right, let's keep going. We'll clean up our network just a little bit, and then we will move on to the next set of tasks to implement, which will be the materials. Again, A, and we can arrange those whichever direction we swipe. And then let's also color these nodes, our prop nodes here, with C to show up this little box at the bottom. We're going to color those to match our graph here, our little diagram. We'll name this our props. The name of this merge node doesn't affect anything at this point. Since we're not setting anything with that actual name, we can name that to whatever we want, and it will not change anything in our scene graph. So we're going to keep going. We could even color these merge nodes the same color as our other nodes if we'd like. All right, next up, we are going to add materials. So remember how we saw in the other network, in our other LOPNet, we had one set where we did the material creation in individual nodes, and then one where we assigned right here each material in its own material library, which is this little container that holds materials, and then each material assignment on its own assigned material node. And the next example we had back in here in our project stage example v2, we did the material creation, all of the materials in this one network. We brought those inside. We brought them up here into our stage context, and we assigned those materials here with the primitives, the paths to the primitives we want to assign the material to, and then the primitive path of the material. So we're going to do it the same way there with only one node for each. So let's do a material library. You can add that in. We'll change the color. Let's say our materials. And now, remember again, this saves it by default to /materials/. So this will add this prefix to the USD prim path whenever we show that. So let's go inside here, double click, and we can do material X builder. So I just did MX. You also don't have to type the full name. If you just start typing the letters, it'll show up. You can also use the Karma material builder, which will have the same, a very similar setup. There's some slight differences that we're not going to cover yet, but for now we'll stick with this one. Let's see which colors we're going to make first. So let's start with our purple. Let's name this purple. Material, color it if we want. dive inside with the double click, and now if we open up base, we don't necessarily have to opening up these will let you plug in other nodes or textures, which we'll do in later videos. So we can keep these closed if we do want. Let's just set a purple color. That's the diffuse color, the base color. And then if we want to adjust the roughness, we can do the specular roughness here. Let's put that to 0.4. 0 would be 0 roughness, so perfectly smooth. And 1 roughness would be full roughness. We'll see that later, but once we get that rendered, we'll see kind of what the difference is in that. All right, now we have this here. We want to bring it up from our material library up to our stage context, and we can do that by clicking autofill materials. This will say inside, I want to get this material VOP, purple material. Again, purple material. I want to fetch it and I want to bring it up and I want to assign it purple material in our material. So our material path is going to be our primitive path right here. And you can see now it's /materials, and that one we just created it right here. If we wanted to move it underneath our materials, we can do two things. We could just change this thing, this right here, this prim path prefix, to our materials, and then it will move it. You see, we have to have this extra slash, excuse me, move it there. Another thing we could do, Control Z to undo. We can remove this, shake this, and we could use a similar graph to branches. So I'm going to do Y to cut those, move this here, and merge materials. Now I want to take everything on the right and I want to put it in our materials. Again, arrow keys to go up and down here, our materials, and now I just select these, but I don't need to select those now. We have materials saved underneath our materials. So either way is fine. The graph branches helps a lot if you have bigger setups that you're merging in. So let's just leave that for now, just to do it a little bit differently than we did in the last example. All right, let's continue and we'll name that, or we'll color that. Actually, we can leave that same color. So let's go now and assign the material, and then we'll continue making the rest of these. So to assign that material, we use an assign material node. We're going to color this also to match. And let's name this assign our materials. This, we want to delete this one because we want to choose what primitive we want to assign it to. We want to assign purple material to the purple box. So let's say, select this assign material node. Again, we can either type it out ourselves or we can drag and drop. So let's do box. There we go. Now if we select this display flag, we can see in our scene view, the material is now assigned to our cube. So let's continue going and we will assign, we'll create the other materials. We can again alt drag, and let's do next let's do the blue. Let's do a blue metal material. Whoops. This one you can dive inside, but there's nothing here. You actually can't add materials. So say we wanted to do this one, Karma. You see, you can't add that because it's only for assigning materials. You have to create them in our material library and then you assign them there. You can also assign them here with geometry path, but it's easier to stay organized in my opinion, but you're welcome to work either way. If we assign it here, because we might want to make a material, say purple, and assign it to the sphere, the cube, or later down in our graph, we might want to assign it to multiple things. So having that assignment as a separate branch in our graph or a separate area of our graph is going to help us stay organized. Just did it again, whoops. So U to go up, jump into material library. Now we'll make blue metal material. All right, make it blue, double click to jump inside, and we'll change this to a blue. And now metalness, metallic, this will define the metalness of our material. So if it's 0, it's not metal. And if it's 1, it's full metal. And you can blend between these two. In certain types of shading, there's some materials that would either be a full 0 or a full 1. But since we're just doing a render for fun and for learning, we're just going to put it to 0.4, just to have a little bit of a blend between the two. U to go up, again, U to go up. And now you'll notice our material that we just created is not here. Again, autofill materials will say, okay, find what's inside here, blue metal material. Find blue metal material and assign it to the primitive path, blue metal material. And again, these can be different. So if we had blue metal material fancy, it'll change that, but we don't have to change this. We could also change this to extra fancy if we did more material setup. And now it will remember that we changed that and it will assign it to fancy. We'll delete that and bring this back to what it was. And now there we go. We got our blue metal material. So let's do our orange. We can Alt, and again, this is Material X builder. So orange material, color this one, C again. Jump inside, select the Material X standard surface, and now we're going to set it to an orange. U to go up, again U to go up. And now let's do our glass, and then we'll bring them back up to here and import those into stage. So for glass, that's another setting we'll be changing. Red glass. Let's say material as well. You don't have to have material. I'm doing that now for an example, but you can name it whatever you want. Let's now change this to a red. And under transmission, we will increase this. Let's do 0.8. It might actually, if we set transmission to 1, we'll cover this later, but it does sometimes affect base. So this might be irrelevant if we're changing transmission. Inside the subsurface, this has a similar effect, which we will also get into later once we do some shading, on our next few projects, which will be a lot of fun. So U to go up, we just set transmission. We set this color, and our base color, we're also going to set a transmission color. Let's do a nice little red here. U to go up, change this color here. Again, U to go up. And now if we click autofill materials, that will bring them up. Scroll it down here, we can see, and assign those to our scene graph path. Now another material we might want to actually add is for this the back wall. So let's do that one again. From scratch, let's just do it. Material X builder. Oops, double check to make sure I typed the right one. Material X builder. Select white material. Change this color maybe to gray. Jump inside. We're going to change our base color and our specular roughness. Let's go crazy. Let's do 0.6 for this one. U to go up. Again, U to go up. Autofill material, and there we go. Now again, we could assign to our geometry here, but remember what we talked about in the last part of the lesson. Houdini does not know anything about the rest of our geometry because this node here is disconnected. So if we look here, we can see there's no scene graph path, or inside this scene graph path, there's none of our geometry. So Houdini can only operate again, remember, on the information above. So right here, we can't assign this material to the cube because as far as this node is concerned, there is no cube. So if to go here, and now we can see the geometry we have here. And now in this stream, whoops, I just disconnected that, but I'll click and connect it again. Now in this stream, we're able to assign that because it has both the prop geometry information above here, and it also has the material primitive information, which we just created and branched in with our graphed branches here. So in our assign materials, let's do 1, 2, 3, 4, and 5. So let's assign next our orange material to the big sphere. So we're going to go here. We'll delete this. We will find our primitive we want to assign it to, big sphere. And we will assign the material we would like to assign, orange material. There we go. Let's do it again, but this time we'll do dragging and dropping. So we want to assign now the blue to our blue rod or tube. So we're going to select this assign material, click and drag. blue metal material to material path, the material we want to assign, and then onto the primitive we would like to assign that, tube. And let's do the next one by typing, just to get some more practice. Our props, again, the arrow keys go up and down here. Let's do the small sphere, and we're just going to select everything in the small sphere primitive. Our materials, materials, and this should be our red glass. There we go. Now this is showing as a glass material with the transmission, so it's going to look a little bit different in the viewport, in the scene view, excuse me. But when it renders, we'll see how this looks, and once we add our lights, we'll be able to render. Actually, we can render now, so there's nothing wrong with that. It just wouldn't make sense. So there's no light, so it adds a default light, and it shows some kind of render which we wouldn't want to have. So if we added the scene lights, it'll show a little bit better of a view, which we'll do next. So back to Houdini Vulkan VK, and let's keep going, and we'll assign the last one, which was our material to the ground. So now let's select white material, material path, and now you see it's an error right now. Also another thing, with errors we can hit this node info, and it'll give us an explanation for what this error is. We can also hit this I info, this little I tag, and it'll just show us information about that node. This will be helpful later, and there's lots of things we'll be doing with this one. Again, I shows information, and if there is an error, it'll show you with this little mark right here, and we can read what happened. So it says failed to bind material onto primitive. So it can't assign this material to the primitive, which makes sense because this primitive is just our root primitive. So there's nothing really here to assign it to. So we're going to go, our background is where it was, and now we could select floor. But if we did select floor, it would only assign it here to the floor. In this case, this one's the floor and not the background. We could, if we wanted to, create another material assignment and assign this one to our background and wall. We can copy this string, this path, and Control V to paste it. And now that assigns it to the floor here, and then also assigns it to the wall. Another thing we can do, I'm going to X this out, and another reason why organization here is very important is if we do our background, we can do this, an asterisk, a wildcard. That'll assign it to everything underneath here. There's some exceptions to that, but for now, since there's no materials assigned ahead of time, that will assign it to everything underneath here. So to show you a little bit easier, let's do one that we could see with the color. I'm going to disable that flag there. Orange material, and there we go. It assigns it both, again, to the floor and the wall. So if we just did wall, now if we wanted both of these, we just do that wildcard. And let's put this back as our materials, materials, white material. All right, let's keep going. That was creating materials. We added all of these, and then we assigned all of these. And remember, we did that in one node for creating and one node for assigning. Next up is going to be the lights, and then cameras, and then render. So let's make a little bit more space here. And let's start with the lights. So I know we're going to have multiple lights. So I can add this merge here. And then we can start typing light. And there's lots of different lights you can use, but we're going to be using this one, and then we're also going to be using a dome light. A dome light is going to be an HDRI, or an image that is wrapped and mapped to the entire dome, the sky. And that's going to be shining, and it's common for reflections or getting a realistic look in kind of base lighting. You can also do more with those if you want to dive into lighting, which we'll do a little bit more later. So now for the texture, there actually is, if you do hip, let's see if I have it here. Let's see if I can find it. All right, so I'm going to select it here. So to do that, we'll go texture. There's a file you should have downloaded with the project files. So texture, click this arrow right here to go to a file browser, Assets, HDRI, and we are going to select this one, which was from HDRI Haven. Accept. Merge it in here. And now if we did render, we won't really see anything because we're not looking at our scene. If we did want to see this in the background, D, background, display environment lights as backgrounds, will show you the HDRI background, the environment light we have selected, but we don't need to see that now, so let's just hide that. There's also a setting on the dome light under Karma that lets you render light geometry. That's one we're going to get into later, so don't worry about that yet. And later, I mean later videos, later projects on this channel. So continue. Let's now connect this one. We'll look into this one in a second, but let's merge. We'll do graphed branches. This time we'll make it from a new node, so we'll drop this one instead of copying this one. Again, the left side is what we want to merge to, and the right side is what we want to merge. We can set this flag display, and we want to merge everything on the right with our scene here, and where do we want to put it? So right now, with just this, it put it right here at the root. So this is under lights, and we want to put it under our lights. So we can drag and drop, and now we've assigned these primitives, these lights, onto our lights right here, and we can see our lights. Now let's color these. Let's do a brighter yellow maybe. And then for this light, which currently is just a point light, we're going to make it a sphere light. So a point light is a infinitely small point in space that has the light emitting from it. A sphere will have a radius, so we will be able to get soft shadows. Again, escape here, I can hit enter to see this handle that we see here. We can click and drag, so say we wanted to move it on everything but the Y. There we go, let's lift it up. And now this right here is a preview of how big our light is. So radius is 0.5, we make it smaller, and we can make it bigger. Let's stick with 0.3 maybe. Move it down. And now let's see where this light was. It looks like from this image we can see this shadow here and this highlight. So a light must be coming from this direction, maybe slightly behind the sphere, because the shadow is coming a little bit in front. So let's do that. We can move these also once we start to render. So let's actually do that. And there we go. Remember how this looked bad when we were above here? That was because we had no lights and our scene was just rendering the geometry without any lights here. If we want to see our lights, again, we have to go down because Houdini here knows nothing about the information below. So we're going to go here, let it refresh, and there we go. And it's looking pretty good. And then again, if we hit D while hovering over the scene view, we can see background, display environment lights as backgrounds, and then we could see the HDRI, the dome light that we just added. We're going to hide these because we don't need to see that. But let's keep going, and we can again hide these icons here that show the lights. With this, we'll be able to hide the cameras, and this one actually does. It has hides what you have selected. So we don't have anything selected yet, but if we had the cube, let's do box. You see this orange outline? If we hide this, yeah, but we don't need that one, so don't worry about that one yet. Just hit escape, and now we're going to stop this render here and keep going. So next what we want to do is add, let's do another light because there was a light behind here on the left. So let's duplicate this, Alt drag, and now you can see these lights are being named by the OS, the dollar operating string. This is the name of the node and it's being saved. That name is being saved to the primitive. So now we have light 2. We select it, it's saved as light 2. Merge it in, and there we go. Now it's right here, but it's in the same position. So if we select this light, hit enter, while we're hovering over our scene view, we can see this handle, and now we can move that other light. Let's put it back here. A little bit lower. Maybe let's make this one smaller. Now escape to hide that. And great. That's good for now. Let's organize this a little bit. A and drag A. And let's say this our lights. Let's say merge lights. Awesome. Let's keep going. Make a little bit more space. And we can do our camera. There's a few ways to add a camera. We can either tab in a camera, or what you can do is position your view in the 3D scene, and then you can go up to the top right here, new camera, and that'll create a camera from where we currently are looking, and you can see it's red, which means we are having the camera locked to our view. So if we move this, it'll move the camera. Control Z to undo that. If we wanted to leave the camera where it was, we have to click this lock button to disable locking it to the view. And now if we move, the camera is going to stay exactly where we are. Let's position this one not by looking through it, but with these gizmos, these handles. And the camera actually has a cool one. We're able to select where it's looking, the target, and also move the camera here. So if we always want to be looking at the center of our image, our center of our props, our scene, we can do that. Put this arrow, this handle at the middle, and then as we move this around, it will stay focused in this direction. So let's lift this up a little bit. Again, M, we'll choose whether it's in world space or local space. M, let's raise it up a little bit. And now we see camera 1. Let's name this to our camera. Let's do our camera A, because we'll add a few shots here, a few cameras. So now I select, now we look through our camera A. Now, inside this camera, again, it's named camera as an operating string $OS. We can also set the aspect ratio. So 16:9 is what we have now. There's some presets here, but what we're going to do is 4:5. So this will be the 1080 by 1350 we had earlier. And then let's click this lock button, move it around. And now you can see our camera is a little bit skewed. So if we see here, transform, we can reset our rotation, which was this Z here. And let's find one that looks a little bit similar. We can also change the focal length here, 50 millimeters currently, which is the same as real cameras, and other softwares have the same framework here. So let's say 25 or 24. This will be a wider angle. We can even go extra wide, wider than we would be able to in the physical world, because this is 3D, so 10, be a super wide lens. Or we can go 80, 85 millimeter maybe. And you can also go, you see, extra tight. So if we did want to go very, very, very zoomed in, we can go farther than physical lenses can go. So let's do maybe 85. And let's position this camera. Actually, look, we can see these perspective lines. This might be actually closer to a 50. So let's arrange that. And now, again, the red here is showing that our camera is going to move with our view. If we uncheck this lock icon, that'll say, okay, stay where you are. And when we move, the camera is going to stay there. Again, I'm going to turn this off. We don't need this one. All right, our camera A. Our camera A, great. Now let's make another one. What I just did is I held down Alt there, clicked and dragged, and it put this little node. So this is like I can also hit Alt and click. These are things you can use to organize. So if you want to organize your network, you can place these, Alt, click, and you can move them around. One other thing is, remember how we talked about how Houdini can move information only down, and it can only go down a graph? These little arrows, if you do have a wire that points up, Houdini will let you know, hey, the information is going up. So it's going along this arrow, and technically it's going down still. So it's going from a node above to a node below, but the node just happens to be positioned below. So a quick tip for you to keep track of there. Let's delete this here. And now what we're going to do is shake to release our camera B, put this back in, and our camera B. Now we just zoomed in, but we didn't have the lock selected, so the camera didn't move. But let's make this one a wide angle lens, and let's go above. All right, let's look at our scene from here. So escape to hide that information, enter again to show it, shift F1 to show and hide these hints. There's also things we can do later, which we'll actually use for a focal length. Unlock this so it's not following our view, and now we're going to move. Now our camera's there, and the other camera we have, camera A, is right here. We can hide these, but let's keep going. Select these, A, drag. We'll let you arrange them again. All right, we're looking up next, and now we need our render settings. So this node we have already covered, we've seen it, it's the Karma render settings. This defines a lot of information about what we're going to be rendering, but for our case, this is going to define the resolution and the camera actually. So what we can do is we can select our camera, camera A, and now if we are in render settings, what we can do is up top here in cameras, we select render settings camera. This will have our scene view automatically pick and use whatever camera is selected here in the render settings. So B, A. And this will only work if we have a node below this selected. So if we select B here, see A, whoops, I'll show you B, B, this won't actually change it. So now if we have B selected, we're still in camera A, because we're now having our display flags. So we're reviewing this node, the information on this node, but our render settings are being assigned the camera below this node. So we select that one again, select render settings camera, and now we have B, A, and B. One other thing is actually now, if we click lock and move this camera, it will move our camera. But if we had it organized in a different way, and I'll show you actually a third camera now, just to show you that. If we had our camera C, so Y to cut, C, and if we did a graphed branches, so Y again to cut, drag and drop, this will align it right here. Let's merge this camera onto, not here, which right now it's just assigning. Actually, see right now it's assigning to our lights. So you see graphed branches has taken this camera, our camera C, and assigned it right here under our lights. So we want this actually to be under camera, so we can drag and drop, or just type it out. And now cameras will have cameras. So this second one here again is because this node here has set a primitive path extra, so /cameras/OS operator string, and it's now adding that whole entire path to this entire path. The reason these cameras do not have that extra layer is because right now they're just being set directly in cameras, and they're not being merged with this additional graphed branches. So let's do, to fix this, we could either just delete this, and it should put us in cameras, and now our camera is where our new camera should be. So let's see actually what happened. Cameras is our camera. All right, it looks like this overwrote all the primitives we had saved here. You see these cameras disappear. So what we want to do is we actually want to select this path, and now that's going to put it there. And if we wanted to get rid of this cameras, what we can do is we can delete this additional path here for our primitive path, save it just to $OS $operator string. So again, the name of our node, and there we go. Graphed branches has now merged camera onto the same primitive where our other cameras are. Now, what I wanted to show you, again, whoops, Control Shift to undo, or if you do disconnect that, you just click and connect, is if we select our camera C and we move it, what it's going to do, right now what it just did, is it dropped down an edit camera node. So this is ways we can edit our camera, and you see since we're not in the same stream here, the same line, this edit camera has been appended to our graph to transform this primitive. So our camera C comes in here in this location. Let's see our camera C here. We'll select it in this location. This camera, this node, edits the camera's location by this amount. So tab again, and we can see. And now if we select this node, it's moved it. We can bypass this node to disable it. So if you're setting up maybe shots and want to animate the camera later, or if you want to do certain things like that, this is a helpful thing to know, and to know why it happens if you drag and drop, or excuse me, not drag and drop, if you rotate in this viewport in the scene view with this lock selected. Now, if we select A and move, you'll notice that doesn't happen. So that only happens when we've crafted the branch in from a different area of our graph. So that doesn't happen, and if we select C, because we already have that edit camera, it's going to append or update that translate right here. And let's actually see together. This null, I can place this here, and we're going to be looking at the same scene. But let's see what happens if we do C, our camera C, and move it here. All right, it looks now, since this is in the same stream here, not grafted in, it's going to append to this edit camera. So that's a good thing to keep in mind. And also, knowing, I'm going to delete these also, just because we don't need those yet. Knowing what's going on with your primitives and where they are and what is happening to each primitive is going to be helpful. So that's a good thing to keep in mind as we're working, and also try to stay organized, because that's going to help us a lot later. All right, now we have, it looks like our full scene. We select XPU, the render engine we want to use. We can hide the camera, and we can hide the light. All right, now if we want to do a few things, maybe we want to zoom this camera in a little bit more. So we'll do camera C. Actually, let's do camera A, and we'll move that in. And let's try to line that up with our shot here. All right, and you see we have this little reflection here. So what I'm going to do is I'm going to hit this lock icon, and now I'm going to move out, and I'm going to see where this light was. So I'm going to actually turn off our rendering. So this light, which if we can look and we can see, light number 1, this was the one that was giving us our reflection. So we can go back to our camera, camera A, see where that is, and then maybe move that. Another thing we can do is actually, if we wanted to, we could disable these. So disable dome light. And now we just see this light here. We can disable this other one behind. And maybe we want to increase the exposure. So we can bump that up. It'll take a second to reload. I'm going to hit Shift and F1 to hide those tooltips. And now we can kind of see where our reflection is showing. We can also change the color, and we can bump the exposure up as bright as we want. And now again, this sphere, the radius here of the sphere is the radius of the light. So the shadows will be softer depending on how big our image is, or how big our light source is. So if we put it to 0, 1, that'll make it dimmer. We can also normalize the power, which would, if it is a smaller radius, it will normalize our intensity to have the same exposure value. So same contribution to the scene. And now if we make this 1 exposure, but 2 for the radius size, we can hide this to see. This is actually a good tip to use our shots, so our snapshots. Drag this down. And one thing we can actually see is this little crease If we toggle this back on, that's because the light, the geometry of the sphere, is how Houdini is creating it, is actually intersecting and giving us this artifact. So if we don't want to see that, we can just make it a little bit smaller. So 1, and now it's doing this again, so maybe we'll move it out of the way. So select our light, enter, we'll drag it along the X. Hide this again. And now what we're going to see, let's wait for this render to finish. Again, it might render a little bit slower on your computer depending on your hardware. So we'll do a snapshot to take a preview. Let's name this large, light, soft shadows. And let's do the same light. And what we can actually do is we could change this to exposure 1, or whoops, not exposure 1, radius 0.01, which will give us the hard shadows. So let's wait for this to finish and then we'll take a snapshot. But for example, if we were looking at these and comparing them and we wanted to say, all right, I really like these shadows, but I forgot what value that I had. So I don't remember what shadows we had or what radius for the sphere light we had to get these shadows. What we can do, I'm going to X this out, is we can use what's called a switch node. So in Houdini, this is a very common node. This lets you select between multiple inputs. So I'm going to shake to release, set this, let's keep this as 0.01 and then duplicate this to point, for the radius, let's set this to 1. We're going to merge this into the switch node, select the switch, and merge that in here. We can rearrange if we do want these the order of these nodes by selecting these little arrows. So this will lift it up, and we can also recut. So we can cut with Y and then just reassign these by hand. We can also select multiple ones, click, and then it'll assign multiple ones at the same time. So let's go here. We'll go to, let's do our camera, turn on our rendering with XPU. And now, instead of changing this value, if we had maybe a more complicated lighting setup, or maybe another merge with multiple lights connected in, which we will have later. I'm going to delete these for now. Actually, I'll leave these because you can leave them and that doesn't affect the actual scene graph. It's just another organizational tip that you can do. So if I hit 1, that's going to switch. It's going to switch our input from 0, which is the first. In Houdini, 0 is the first index. If you've done programming or used Houdini, that's probably familiar, but if it's new to you, everything starts at 0 as the first index and then goes to 1 as the second. So 0 and 1. Now this is an easy way to switch it. And we can also switch this with anything. So if we wanted to switch assign materials, let me do that actually now just to show you. So assign materials, switch. And now if I go back here to enable our light, I'll clean this up in a little bit, don't worry. And now if we selected this, we can Alt drag to duplicate it, connect it here. And now in this assign materials, if we wanted to set that input, that node that is connected right here, to be coming into the switch node, we can set it to 1, and you can see this little change here, the dotted line to the solid line. That will change it to using this right assign materials node. So the right is not the left, not the correct one. They're both correct depending on how you want to be working. So now if we wanted to assign maybe our blue material to the box, it'll assign that. And now if instead of our maybe red sphere, actually, now that I'm looking at that, this is a good example to go back. So I'm going to show you how to fix that transmission issue right now on the glass material that we're supposed to have. So let's clean up. Control will let me drag and move everything below. I'm going to disable our render. And let's organize a little bit just so we're not working in a messy network, because that's no fun. A. Shift S, again, remember, you can choose what node wiring you like to see. Totally up to you. So let's keep these as our lights. Let's move these down. And then our materials we'll leave here. Let's color our switch node just to match. All right, now what we're gonna do is see why our glass was not looking like glass. So let's fix those. All right, so if we go back to our render, we can see the glass is not looking like glass. So let's jump inside our materials, jump inside our glass material, and see why. So if we set the transmission to 1 and the reflection, oh, whoops, okay. This is a good example here. Metalness. So we can zoom in here and we still see our scene. Looks like this material is getting some metalness as well. So we can disable that metalness. And metalness is one of the ones that will override what we also have selected. I'm gonna pause this. Sometimes Houdini does crash, when you're changing things in XPU. So make sure you do your file save, and you also do file save as. And if you wanted to type a incremental file save, you could do V1. Whoops, not that, but you could do V1, V2, however you want to save and organize your files. Houdini does do backups too, so don't worry too much, but definitely save. Okay, so metalness, if I go back to rendering, has overrides the transmission. So now if I set metalness to 0, we'll see our sphere looks a little bit more like glass, but now it's like a muddy glass, a foggy glass, a rough glass, which is our roughness. So set this to 0, and there we go. Set this to 1 is full roughness. Let's do a 0.01. Another thing about this is, since this is refraction, there's also number of times that the light will bounce when it's being rendered. So I will show you very fast, but we're not going to worry about that actually. In our Karma render settings and limits, there's a refraction limit. So if I set this to 0, and again, you see, I set this to 0, but nothing happened because I'm not selecting that node. So I have my display flag up here, but I'm trying to change stuff here, and I've even clicked on this node, but I need to set my display flag for the scene view on the node I want to actually be looking at. Give it a second. And there we go. So now it's not refracting through the glass because we've set our limit to 0. Whoops, I don't want to do that, so cancel. I'm going to save, and now if we set this to 1, we'll see 1 refraction through our glass. And we can also, this is another good example, these, the text, the numbers, when they get a slight bold, a thicker font in our parameters here, that means they've been changed from the defaults. So if we right click and say revert to defaults, it'll change it, and you see how that bold went away. Right click, revert to default, or I might control click and middle mouse button. So that's a good thing to know. And if you ever mess up any settings, you can just revert those to default. So let's leave it at 4. And now we will go back to continue. We'll dive into these also later. So once we get more complex shading and rendering, we'll dive into these with render layers and AOVs, which is going to be another thing. Probably a few videos actually down the line. So red glass, let's add a little bit of our roughness back. And there we go. We can also change the transmission. And let me show you actually another thing. The color here is another one of these parameters that is overridden by transmission. So if I set it to green, you might say, why isn't my glass green? Because this value, this color, is being overridden by this color right here. So if I set this to blue, it'll be blue. And maybe we want a, let's do a yellow. Let's do this. I kind of like this color, so let's leave this. You can see some nice refraction in the lighting being changed too, which is really great. So U to go up, again, U to go up. We'll go back to our camera, Houdini VK, Houdini Vulkan. We'll save. And then let's render this out and call it a day, actually, because we've covered a lot. So the two ways, again, we can save the image to our disk, to our computer. We can wait for it to render and take a snapshot. This will be a good example because I'll show you our render ROP we'll be adding. Snapshot, Houdini VK Vulkan to turn off our render. Double click this. Right click if we do want to, set to aces. I just like looking at it, but you can change if you want or you don't have to. So save frame. We'll do hip. And let's do render. I think they were in before. And let's say our second. Second. .png. And we will do bake to open color IO, which is going to bake this transform into our file. All right, hip current folder on disk / render, so folder, subfolder render, and it's going to save our file here. So save, give it a second, and now if we open up our background image, you can also look with your file browser to render our second render. There we go. Now let's do tools, edit background image, and let's do a null. And now we'll connect that, and now we can move that around. Awesome. So we just finished our render, and this is a little noisy. That's because we don't have enough samples, but we'll cover that in later lessons. So we just recreated our reference. Oh, one more thing actually, the USD render route. So if we do render and we want to save out multiple files, or we don't want to jump through these hoops right here, what we can do, USD render ROP, render output. Let's say save our nice render. Actually, this is an extra nice. Save our extra nice render, because we're well on our way to learning Houdini. So file, save. Let's color it. And now, where do we want to save it? First, we'll set Karma XPU. I'm going to middle mouse and see what happens here. We can define the render settings we want to use. So if I drag and drop, that will set which render settings are being used for our render ROP. We might have multiple settings in our network that are changing different things for different parts of our render, which we'll get into later once we set up bigger scenes. But for now, we select that one. Our camera, we don't want to override it. We do want to select Karma XPU, and we do want to render the current frame. Now, where are we going to save that image? Right now, it's going to save it to hip, so current folder, where the file is, render hip name, which is the name of our Houdini file. But we don't want that, so let's delete these, and we'll do our, you see the other ones pop up that we did do. Let's do our second render USD ROP. .png, and again what we could do underscore $F4 if we did want to add a 4 integer padded frame number. That is very important for animation, otherwise every image you render is going to override the last image. So render frame 1 will be written to disk, and then if you forget this for animation, render frame 2 will just write the same render on top of that same file, and you'll be left with one render done multiple times, which is a waste. So make sure you name that with $F4 if you want your frame numbers. And we'll do click here, double check everything's correct, which it looks like it is. Actually, let's do our camera A. So to select that, we go to Karma render settings. We can drag and drop again if we wanted to from our scene graph path. Our camera B is right here selected. We select our camera A, or we could click this little drop down and just change the camera. So now we'll go here, select this. I'm going to double check our resolution. So this isn't the same resolution. If we do change that, it will change it. If we want to set it our manual resolution, we can right click, click delete channels. We should be able to do that. Okay, whoops. So render resolution, right now it's looking at the camera and then computing the height from the camera. So we can set it to manual. But one thing we should keep in mind is what our camera aspect ratio is set at. So we should always stay consistent. So go back to, actually let's leave it manual. We want 1080 by 1350 because that is a pixel resolution that conforms correctly with our 4:5 aspect ratio. So select render settings. One more thing, actually, we do want XPU. So we'll select XPU. And now render to disk. All right, I am recording, so it might not pop up, but let's give it a second and we'll see how long it takes. So if we wanted to load it in, if we assumed it was done, we click this image up here. Nothing's popped up yet. Let's wait and I'll debug it with you if we're not working. So there we go. Okay, so it just took a few seconds. It might take longer on your computer. Don't worry about that. You could render if you want to see how long it takes to render, or you're worried about it not rendering, or you're getting issues with that. What you could do, just for now, we'll cover later in different videos how to do it a different way, but you could render your image here, watch the progress, and you can see an estimate of how long it will take and how long it will take here, and then how long it has taken. Our render's done and we can click snapshot. So if this was maybe a 5-6 minute render, it might be helpful to just be watching the progress and then saying, okay, this is a quality of render I'm fine with, and then stopping that render, saving it, and saving to disk. So let's load this new one in. So again, create background image, our second render USD ROP. Remember, our frame number was named with our $F4 named right here, and we're on frame 23. And now again, like we've discussed before, our color is not the same because we did not bake our ACES view transform or color space transform into this image. So add a background image, connect this link, and there we go. Awesome. All right, well, we just finished everything. To recap, let's show our scene that we just created from scratch. We got our background. We started with some empty primitives. We added in our background. We did our props. We merged in our materials. We learned how to do a few different setups of materials and even a few switches to control our network. We added lights. We learned a few things with lights. We added our lights to our graph, our scene graph. We added some cameras. We learned how to move and transform a camera. Actually, one thing I'll show you, I'll continue this, but then I'll show you how to set a focal distance. So Karma render settings, we set end, then we rendered with a USD render ROP. Now, if we wanted to add depth of field, we could go to camera, let's do A, we'll select our camera here. We're going to enter the camera, so enter the camera view again by selecting this button. We're going to lock it to transform. So now we're controlling our camera if we move. We're going to zoom in, and what we're going to do is hit Shift F1 to see our hints. And now what we can see is if we hit Shift F, we can see our focus plane rendering. So this, if we hit Shift and click now, we can select where in our scene we want to focus on. And now in order to see that, we'll first need to shift from perspective in our Houdini Vulkan, our viewport, our scene view, into XPU. And now you'll see this doesn't actually do anything yet. So I'm going to hit Shift F1 to hide that. What we need to do is go into our camera and change one quick setting. So select our camera. The camera we're looking through is our camera A. We're going to select that. We're going to go into Karma. Oops, actually no, we're going to go into sampling, and we're going to change our f-stop. So our f-stop is our aperture, like a real camera would have. If we set it to a number of 1, the lower the aperture is, the more of a depth of field effect we will get it in our render. So escape to hide that. Again, if we have our camera selected and we hit enter, Shift F1 to show the tooltips, we can hit Shift and click to select where in an image we want to focus. Hit escape to hide that, and again our f-stop, and you see this also does change again our focal distance, our focus distance right here. So we could change that with this setting. This clicking is an easy way to select where in your scene. So escape, and let's set our f-stop to maybe 0.8. Actually, let's do 0.5 so we can see a little bit. We'll let it render out, and then we will save this up to our snapshot and then recap a little bit more about what we've covered. Just finished up. Snapshot, save it. Houdini Vulkan, turn off our render. Double click. Color correction, and we're going to go to aces, and there we go. This image here, I'm going to double click it and it's going to make it bigger. This image here is the first render we've done, and there's no depth of field. The next one does have our depth of field. All right, we're looking good. Remember, these were the lights we had set up with our radius for the sphere light to set up soft and hard shadows. So X that out, unlock that, and there we go. We just finished. We just set up our whole scene. We implemented all of these tasks, and we told Houdini to create our scene, to render it. We controlled everything here, and now we have a nice organized scene that we just created 100% from scratch by following along. Awesome. I'm going to cut again, and then we're going to review the whole lesson and talk about what we're going to learn next. Congratulations and welcome back. If you've made it this far in the video, you've learned definitely a lot of information, I hope. And if this is your first time ever opening Houdini, I hope it was not too much of a mess and at least a little bit enjoyable for you to use. We've covered a lot of information, so if it does take a while for this to sink in, don't be discouraged. You might have to watch the video a few times and maybe even follow along with the follow along section of this lesson a few times. We created our whole scene, our whole shot from scratch by looking at our reference, and we also learned a lot about what was going on and how Houdini works in ways we can leverage in order to better work and better stay organized. So if you did enjoy this video, I would ask if you could share it with other artists. A lot of work has gone into organizing this video and creating and recording it. So it's been a lot of fun to actually make, and I really do hope that you get something out of this and you enjoy learning how I approach Houdini, and maybe even get some tips on how you can approach it or new workflows on how you can continue to learn. So stay tuned. We're going to be covering a lot of exciting stuff in future lessons. We're going to be expanding on a lot of this. So do keep this as a foundation. We will keep getting more complex and keep reviewing these fundamentals. So we will build on all of these things we've covered so far and keep learning and making more cool renders. So we'll keep cooking and having fun in Houdini. So thanks again for watching, and I hope you have a good one. I'll see you in the next video.